Okay. Hello. Thank you for joining our Veeam Backup and Replication technical onboarding session. We have the Q&A chat. You can find it somewhere in the right upper corner of your window. So just feel free to engage anytime. And I would be highly appreciated if you could just somehow let us know that everything is working, that you can hear us, that you can see us, and you can see a content. So let me check. All right. So my name is Elena. I'm a certified system engineer here at Veeam Software, and I'll be guiding you through the first part of today's session. I'm also happy to introduce my colleague Gabriel, also a certified system engineer, who will be taking over the second part of the call. Together, we'll walk you through the essentials. So to get you up and running with Veeam Backup and Replication. So a few quick notes before we begin. This session is being recorded. So you will receive the recording shortly after the session within a couple of days. Also, we will send you your slides and all of the content. Well, anyway, however, I highly recommend you to stay engaged and take all the benefits from the live session. So feel free to ask your questions in the Q&A chat. So while the first part, my colleague Gabriel will be helping you in a Q&A, and the second part, I'll be answering the question there. So your microphone and camera, they are disabled for the entire session. So the only way to communication is through a Q&A chat. And if we are good, we can begin. So, agenda. Today's session is designed to give you an understanding of how Veeam works. So from deployment to day-to-day operations. So here, what we will cover today. We will begin with a quick look at Veeam Data Platform, just to give some context around where VBR fits in the bigger picture of the Veeam product family. We'll break down to the core components of the VBR infrastructure, so you can understand how everything connects, what kind of components we have, how they talk to one another, how to start working with them, which of them necessary and which of them auxiliary. So we're going to go through advanced feature. We introduce you to optional components that can improve performance or meet your specific needs. For example, like a tape, servers, WAN accelerators, and more. So we're going to go through product configuration. So the initial setup, step by step, how to start, where to install VBR server, what to do with that, all the practices for configuring the solution. We will discuss backup jobs and policies. So how to create, how to manage backup job, what's the backup copy job, how to create and manage this one. Recovery capabilities, that's important because the backup is the halfway and the main idea is to be able to recover in case of a disaster event. So we're making sure that you're prepared for the worst case scenario. And of course, security needs. That's important nowadays. Nowadays, it's critical, so we'll review all the security features which Veeam offers, and a little bit of tips and tricks. So we share some useful insights and practical takeaways from the field. And we also offer you additional resources after call. In the last slides, we will show you all the useful resources in university, how to videos, link where to find all information which might be useful. So also I will disable, turn off my camera right now in order for you to better see content, but I'm here. So turning off the camera and we continue. So let's talk about Veeam Data Platform. In this section, we will discuss the Veeam product and version supported by Veeam and take a quick look at how licensing works across different editions. VBR is a core part of the entire Veeam Data Platform. So the Veeam Data Platform is available in 3 editions. So firstly, this is the Foundation edition. This offering includes VBR functionality. It supports the backup for wide range of environments. The on-premises, hybrid, multi-cloud, so you can back up with the VBR, the VMware, Hyper-V, Nutanix, AHV, AWS, Azure, Google Cloud, physical systems such as the Windows Server, Linux Server, IBM, AIX, Oracle, Solaris, and etc. Applications and platforms, Oracle, PostgreSQL, Red Hat, Proxmox, and more. Additionally, we have Advanced Edition. So this built on the foundation. And here we adding Veeam 1, which provides the basically monitoring and reporting. So with a Veeam 1, you can do analytics, alerting, forecasting, security insights, and just the general infrastructure monitoring. We are not covering Veeam 1 today at all. We have a dedicated technical onboarding session for Veeam 1 as well. So you can check our portal for recording or for upcoming live session for Veeam 1 if you are considering Veeam 1. So here's the part of it. And we additionally have a premium edition. The premium edition includes everything from the previous tiers and adds Veeam Recovery Orchestrator. So Orchestrator is a powerful orchestration and automation tool for disaster recovery. Name speaks for itself. So we basically orchestrate disaster recovery process. That's great for planning and for testing and for automating large-scale recoveries to different targets. You can orchestrate recovery to your disaster recovery site, to Microsoft Azure cloud platforms, to the different scenarios. You can utilize the recovery to disaster recovery from replica, from backup, engaging the storage integration with the NetApp, Nimble, etc. But again, this session is focused on Veeam Backup and Replication. So we have dedicated onboarding sessions for Veeam 1 and for Disaster Recovery Orchestrator on our website. If you're interested in them, so please also visit our website and sign up for the next session. But we will proceed with Veeam Backup and Replication. And once again, I remind you to stay engaged. Any question that you have, please address them in a Q&A chat. So let's start with the very basic things. We're going to discuss what platforms we support, just for you to understand if your current environment meets all the requirements. So virtual environment. Generally, Veeam started with supporting VMware and Hyper-V, but now the list is much, much broader. This is a VMware vSphere, of course. So currently we support up to 8 update 3 version from 6 Hyper-V, including Azure Stack HCI, also Nutanix HV, Oracle Virtualization, Red Hat, Proxmox, and others. So here's the note. Actually, we do not support free ESXi, free vSphere hypervisor, because its API restrictions prevent snapshot-based backup. Also important, our virtual machine protection is agentless, meaning that you don't need to install agent inside guest VMs. We use native APIs of the hypervisors to perform image level backup. So this is what comes for virtual platform. Physical infrastructure. To protect physical systems, we use persistent Veeam agents. That Veeam agent for Windows, Veeam agent for Linux. So also Mac OS, IBM, AIX, and Oracle Solaris. So you can find all of the agents on a Veeam website. You can download them and start using. We will talk further about the licenses you need to operate with all different workloads. For now, we are focusing on the general picture, what kind of workloads we support. And let's move forward. Unstructured data. So nowadays, that's pretty important. For unstructured data, we offer pretty much a lot. You can back up file shares, SMB, and NFS file shares, whether they're located on the physical NAS devices and or enterprise NAS system, such as the NetApp ONTAP, Lenovo ThinkSystem, PowerScale, Nutanix file storage, etc. And also object storage repositories. So the S-tray compatible storage might be backed up as a data source. So any S-tray compatible object storage repositories, Amazon S3 object storage, Azure Blob storage, ONTAP, etc. So pretty much if you have any unstructured data, which must be backed up as an unstructured data with an ability to recover the file versioning, to do a rollback for the entire share, not to recover everything, just to run a rollback and gets back to the changes. In this case, the unstructured data, this is the way to go. And since usually we have a file servers which host like millions of files, the normal backup might be quite complicated to perform within the one backup window. And unstructured data utilize different functionalities, which might be the good idea here. But we won't focus much on the unstructured data right now, and we can continue here. So, databases. Within Veeam, we have application plugins. There are native plugins for all popular databases, and we always offer we are working for additional integrations. So currently we have plugins for SQL Server, for Oracle databases, for SAP HANA, for MongoDB, IBM DB2. So these plugins integrate directly with the native database management tools. For example, we have an integration with a SQL Management Studio or with Oracle RMAN for Oracle databases. And we basically do not interrupt as a Veeam into the native process of backing up database. But at this point, we can still continue working with the backup files created by native tools. We can form them in a Veeam native format. We can move them to the Veeam native repository, and then we can continue. We can move this data from the source Veeam repository to the secondary target. The data might be moved further in order to meet disaster recovery requirements, 3-2-1 rule, etc. And cloud workloads. We also support cloud native workloads. For example, that's Microsoft Entra ID, formerly Azure AD. So we can back up and restore users, groups, roles, audit logs, and more. So within Veeam Backup and Replication, you can also perform backup for a cloud workloads by utilizing the cloud appliances. So for example, the virtual machines, file shares, a network configuration of your Microsoft Azure environment. So EC2 instances and file shares in an AWS cloud or Google Cloud might be also backed up with Veeam Backup and Replication. So pretty much everything might be backed up within one console. You can monitor everything, how the database backs up, the virtual environment, physical workloads, workstations, especially if you have remote employees, and cloud workloads as well. So that's pretty convenient to have everything in one place. And here we start the licensing topic, which might seem not interesting because it's not something technical, but we like technical more, but still we have to understand how it works. So within Veeam, we have two licensing models. So some of you might have per socket format, but some of you can be already on instance-based license, which we also call VUL, which basically stands for Veeam Universal License. Let's firstly talk a little bit about the per socket format. Currently, that's the legacy model. It is still available for the customers who already have it. It's based on the number of CPU sockets on VMware and Hyper-V host. If you have socket-based licenses, the only two platform you can back up, this is the VMware and Hyper-V. So that's the limitation for per socket format. For you, that's also we offer the migration process for all our existing customers on per socket format. You can just convert your current per socket perpetual licenses to an instance-based Veeam Universal license. So, what is the Veeam Universal license? It's an instance-based licensing model, which basically means that Veeam Universal License is workload agnostic. You can protect virtual machines, physical servers, cloud workloads, file shares, Entra ID, everything with the same license pool. So you just got instances and then you reassign them within your environment for any workloads that we just mentioned in the previous 3 slides. So I usually purchase the number of instances based on how many workloads you plan to protect. And that's basically we have actively protected instances within the Veeam Backup Replication. Each assigned instance will last for 31 days on workloads, and then it will be returned to the license pool. That's very great and convenient for customers with a hybrid or mixed environments. So that you might combine Entra ID protection, the capacity licensing for backing up file shares on NAS devices, the virtual machine, physical workloads, and pretty much everything. So let's then talk a little bit more regarding also the perpetual and subscription. So just please bear with me a little longer. That's the last slide before we move to architecture section, which is much more interesting. So perpetual and subscription mode. Perpetual, this is the permanent license. So support and maintenance period is included with the license. So you might have the years of support prepaid. This is basically for perpetual licenses, literally mean that it's a one-time purchase. The license does not expire. However, it typically includes 1 year of support and maintenance. And having support and maintenance, that's pretty much important because we have to patch our system, we have to update our system, and we need an ability to contact Veeam technical support if needed. So we just renew support separately every year or every several years. So for the another licensing model, for the subscription one, this is a time-limited license. In our case, it's often 1 to 3 years, includes both the product itself and support for the full subscription term. It expires at the end of the term unless it's renewed. So this is common for scalable environments. So that's quite easy to add new instances, quite easy to grow. And just to summary all the talk regarding the licensing models and stuff, I will summarize that we have two models, socket-based legacy virtual machines only for our existing customers. Veeam Universal License, flexible choice for all workloads, virtual physical cloud, and two duration types, perpetual, one-time purchase, and subscription, time limited with built-in support. So just quite note, if you're planning or already running a hybrid environment, VUL is your best. Okay, I think that we finished with the licensing part. And at this point, we are going to jump to the architecture. So now with the section 2 of our presentation, architecture and core components, we're going to go through backup workflow, key core and optional components, and some design consideration for deployment. And we are starting with the components overview. So what we have? We're gonna consider all the core components of the Veeam Backup and Replication and how they fit into your architecture. So first of all, I think it's important to highlight that Veeam offers a modular architecture, so which helps us to fit in a small businesses, kind of an all-in-one server and large deployment, when we can deploy components, distribute them across our system, several sites with a protected workloads everywhere. So core components, all of them which are listed on this slide, it's a VBR console, the backup proxy, backup server, and backup repository. These components are mandatory and they installed by default during the initial setup, and they form the backbone of the solution. So we have also optional component which can be added later to meet your specific needs. But right now we are focusing on the components that we currently have. So VBR console, the component which is responsible for basically accessing, and this is a UI of our environment. So the point from which you're going to operate and orchestrate the entire process. So the connecting points. So you might have several consoles. The console of the Veeam Backup and Replication might be installed separately, which is might be even a recommended way to the one single connection point for security purposes. So the second in line is the backup proxy. So what is the backup proxy doing? Backup proxy, this is our transport component. This is something, some component without which backup won't run. The backup proxy handles data movement between the production, between the data source and repository. So if the proxy has not enough resources, if the proxy cannot handle a lot of data streams, if the proxy working in an uncorrected transport mode, all of this can affect the performance. The proxy is quite often a bottleneck. And for us, it's important to understand what it's doing, how to set it up correctly, and how to monitor if our proxy has any problems. So you might have one proxy, you might have several of them. You might have physical or virtual proxies, and all of them are going to have their benefits and drawbacks. We will consider them closely in a few slides. But just remember now that's a very important component. The backup server. It's a central management component. So the job engine, configuration database, everything. This is our brain of the entire operation and mastermind behind all the process. And backup repository, the storage location for your backup files. So we will consider closely the different types of repositories that we have within Veeam Backup and Replication, but for now, I want to say that backup repository is also a very important component within the Veeam Backup and Replication family. So it also has to have enough resources to handle data. It has to have enough concurrent tasks. So it should be locates the normal file system to properly handle workloads. So we have to do capacity planning for backup repositories. Also, to the backup repository and how it's set up might affect performance a lot. So we're going to focus on it during today's session. And a couple of words for this slide regarding optional components. We have a list of an optional components used for advanced or specific needs, so which are not listed here. I will just mention them. So it might be one accelerator service for improving performance over slow connections. It might be a CDP proxy for continuous data protection replica with low RPOs. Tape server if you use the tape library in your environment and you want to store long-term retention on tape, the tape server as an additional component will be installed. We also have mount servers, which used for file level or item level recovery, especially from the remote locations, and gateway servers for working with a certain repositories, such as the NAS devices, the duplication appliances, object storages. So all of these components can be installed all in one. They can be distributed across our environment, and understanding how we place them can significantly affect the performance and how the entire process will go. So let's go quickly through the initial installation. If you have already installed your first Veeam Backup and Replication, you know where to start. But we're definitely going to cover it once again. We will briefly walk through the installation process step by step. Where to start? Download the most recent version of ISO file from my.veeam.com. So we sign in under our license administrator account. So we have an access to our Veeam account. We can list the product, and here we can select Veeam Data Platform and got the recent ISO file. So we have to also choose where to install our Veeam Backup and Replication. So the entire VBI server might be installed at the disaster recovery site. So for example, if you have two locations, the primary production site and another DR location, the VBI server itself might be installed on the DR site. So you can trigger the recovery operation right away if the primary site is down. So this is a very important point for consideration where the VBI server is going to be installed, because we expect it to survive disaster recovery events on a production site. So definitely not a virtual machine on a production environment. So, but still it might be a physical closer to production, or it might be disaster recovery site, or it might be even the virtual machine in the cloud. All versions, all options has their own benefits. And also the security recommendation, which we're going to cover later, but still, I just really feel like I need to mention it. That generally we do not recommend, according to our best practices, the VBI server should be placed outside of a domain. It might be its own management domain or at least separate work group for security perspective. But that was a little bit back. So installation. Go to Veeam.com, download the setup package, run an installation wizard. Also, we have an unattended install with an answer file, so we can perform then automatic deployment across the remote office. If you are the backup administrator who managed several independent environments, And for each of them, you need your own VBI server. There is no need for you to run installation manually on each of the site. Build the answer file and run unattended installation mode. This is how the installation wizards look like. So we start execute the ISO on our installation server, which meets our system requirements, which is important. So the all information for system requirements for Veeam Backup and Replication server might be found easily in a Veeam user guide. We have a system requirements section where we list all the system requirements for VBR, for proxy, for repositories, and for other components. So also important to remember, if we have just one component, VBR server, which is also a proxy and which is also a gateway, for example, we have to meet requirements for all components which are going to be installed on this server. Well, regarding the installation for the Veeam Backup and Replication, we run an ISO, we click install. So here you see the three options: VBR server itself, Veeam Backup Enterprise Manager, and console separately. We're going to go with Veeam Backup and Replication, since the Enterprise Manager is an additional component. In a simple words, it's a website for management operations. We will talk about Enterprise Manager during today's session, definitely. And if you need additional console, or you're performing the console installation separately on a remote machine, we can go with this option. But initial installation, Veeam Backup and Replication. So the user account must have the necessary permissions. So all the required network ports must be open. Again, the details are in the user guide. We won't focus on the required ports right now because they might be different, depends on the environment. So for important note, I guess, currently at the backup server, management server is Windows only. Linux-based deployment is planned for the future release, but not available yet. We're expecting it in the next release. So if you're into Linux installation, very soon you can try it. So license activation. When you proceed with an installation wizard, you'll be prompted to install a license key. However, you can just click Next. The wizard will allow you to do that. And in this case, we will proceed and runs in the Community Edition. This is the free version, limited to 10 workloads. Think of it about like 10 instances, 10 virtual machines, or 10 physical servers to back up. And in a very basic edition without any advanced features. But if you don't have a license and you want to try VBI server, you can do that in the Community Edition. Or also you can enable automatic license update, which allows us to basically download license from your Veeam account and install it. And also this option will gives you a temporary grace period beyond your license limit. If your current installation expires, you still will have all the advanced features you have in your paid edition. So then we have system configuration check. The wizard checks for prerequisites. Missing components will be installed automatically. The VBI server might ask you for reboot. If anything fails, you can install missing parts manually during the retry. Or we have also repair mode. If you run an ISO file once again, it will offer you a repair mode, checks for all the missing components and install them once again. We can just click install and proceed. Install usually takes approximately 15 minutes. So we can go to the customize settings here as well and configure Veeam service account. So usually this is default to local system. By default, I'm using the local system account, the configuration database settings. And so once again, currently Veeam is working in a two databases engine. This is the Postgre SQL databases and Microsoft SQL databases. So we do not recommend one over another. So this is absolutely customer's choice. We will talk about the configuration database next slides. If you have any specific question regarding an installation, or if you need the links for an installation in an attended mode or something, please feel free to reach out Q&A. We are here to answer your questions. That's important. So let's take a closer look to the configuration database. It's the brain of our system. It's important to manage it. All right. So configuration database. What's actually it's doing? Stores data about backup infrastructure. So this is stores all the settings and infrastructure details. I love to think of it as a brain behind these entire operations. What exactly is stored here? Basically everything. The configuration of the backup environments, the connected production systems, job settings, history, session logs, credentials, and more. Any settings you configure in a console, it's all saved to this database. So starting with version 12, Veeam ships with PostgreSQL as a default database engine. Before that, we used Microsoft SQL Express, which was fine for small environment, but had some limitations, especially in terms of a database size and performance under scale. With PostgreSQL, those limits are gone, and it's free, which is great for licensing. You still can use Microsoft SQL Server if you want. Both database engines are fully supported. You can actually migrate from one to the other at the point of your needs change. So for example, if you currently on the Microsoft SQL, which might be the case if you've been with Veeam for years and you just inherit database engine from the previous releases before V12, you can perform the migration to Postgre. For those who still use Microsoft SQL Express, the database is limited by 10 GB, and at some point you might hit the limitation. So, and after that, we have to consider where we're gonna go. We go to upgrade to Postgre engine, or we can upgrade to commercial version of the Microsoft SQL. So also here at this point, they're a little bit step ahead, but if you're planning to use Veeam Enterprise Manager, which we will cover later, it's important to keep in mind that all connected backup servers must use the same database engine. Again, if you're a backup administrator for the distributed environment, you have different independent locations with a different VBS servers between them. And you have one enterprise manager as a management component just for your convenience. To make it work, we will require the same database engine across all of your environment. So this you can't mix different databases because the enterprise manager will not be able to synchronize data between them. But we will talk about that later when we focus on the enterprise manager. So about the database installation. So the database itself can be installed locally or on the same server where Veeam is installed. Also remotely on dedicated SQL server. No strict rule here. Both options are fully supported. Local database is simpler and easier to manage. It's absolutely fine for smaller setups, but for larger environments, using a remote SQL server is usually better. So you can take some advantage of like SQL clustering and built-in redundancy to make sure that configuration database is always available. So there is no need for separate license if you run SQL Server on other system from the VBI server itself. So just a performance consideration. Also, hosting the database remotely can help avoid resource contention on the busy Veeam server, especially one doing a lot of backup jobs, processing or heavy restores. Offloading the database to a dedicated machine can improve responsiveness and make it easier to pinpoint performance bottleneck. So when we distribute workloads across different servers, that's easier for us to troubleshoot, to track, to isolate problems. But honestly, I would say that it becomes really beneficial if you're dealing with hundreds or thousands of the virtual machines and the very active backup schedule. For a smaller environment, the local setup works just fine. So one more thing, which worth highlighting. Veeam Backup and Replication automatically backs up its own configuration database. We do not need an additional job for this. That's also critical for recovery and migration. So if something happens to your primary backup server, for example, the hardware crash or ransomware, or you just it's a planned migration, we can reinstall VBI server, clean installation on a new location, and we can restore all the entries in the configuration database from the configuration database backup and get back up and running with all your previous settings intact. So we don't need to reconfigure jobs. All the history, all the sessions history will be preserved. So we don't need to start from the scratch. So by default, the configuration database is stored in a default location on the VBI server itself under C drive, backups folder, Veeam config backup folder. So it is recommended to change it. So we move the configuration back up to our regular repository or to somewhere else, just to make sure that if the entire VBI server is gone, we still have the configuration backup. So also this is important not to back up the VBI server itself. So we don't do backup of the VBI server with an agent, or if there's a virtual machine, we don't back it up with an image level backup through the virtual environment API, because it might lead us to very unfortunate consequences with a database corruption. So the VBI server have to be just a VBI server. So the database is backed up by the default settings, and we don't do anything else. So, and of course, so for the best practices is to keep the VBI server as an independent management component separately from the environment in a dedicated domain. And also think about how we're going to recover VBI server if something happens. This is a quite often situation when we definitely know how to recover our virtual environment, but we somehow keep forgetting about the VBI server itself. So regarding supported database engines, actually the versions of the data PostgreSQL and Microsoft SQL Server, you can refer to user guide. Again, the same page, the user guide section, system requirements. So we have all the information here, and you can also request the links in the Q&A session from my colleague. So I think that at this point we can continue, and I hope I covered pretty much everything regarding the database engine. If you still have questions, refer to Q&A. But we can go and talk regarding the components, the other components of the Veeam Backup and Replication. To understand how the components work, we're going to go through the backup workflow. This is the simple example how the components work together during the backup in recovery. Since I mentioned previously, the Veeam itself is a modular architecture, which means you can deploy it as a simple all-in-one solution on a single machine, or it might be scaled out across multiple servers, depending on your environment. At the heart of it, there is the three main components you need to know about: the backup server itself, the backup proxy, and the backup repository. So also I have mentioned there are optional components such as CDP proxies, tape servers, WAN accelerator, file proxies, but those are only needed in specific cases. If you don't use tape or don't install tape server, if you don't need continuous data protection, you skip the CDP proxy, you only install what you need. We also rely on a rule: keep it simple. All redundant components must be removed, also for security purposes. So now, while you technically can install all the components on a single machine, and that's perfectly fine for a lab, for example, or for the small environment, but we still recommend in a real world setup, it's better to distribute them for scalability, because your environment grows. Your backup window will likely grow too. To keep jobs running efficiently and within acceptable time frames, you can add additional backup proxies. So load balancing. You start with one proxy server. Throughout the time you get small workloads. You need to distribute resources. We add in another proxy server, and then we add another one. So in the default all-in-one installation, all the slots, all the transport efforts will be put on the VBI server. The data processing, compression, the duplication, encryption, retrieving data from the hypervisor, from the source, in all-in-one installation, this is on the VBR. So this is a lot for one VBI server. So let's assign these tasks on the dedicated proxies. Since the proxies are responsible for moving data, so to add in more of them means we can process more jobs in parallel. Similarly, if you need more storage capacity, you can extend your repositories. So for example, here we have one repository on the picture. This is just, imagine this is a Windows box. But if one day you suspect that we are close to the limit of our capacity, we can extend it. We have the functionality which is called scale out backup repository. We will touch more on that later, but there is still option to scale our environment pretty easily and allow your infrastructure growth. So secondly, distributed deployments help with the traffic localization. So imagine you have a remote site or branch offices, and you are backing up the virtual machines that sit in those locations. It does not make sense to send the traffic across the WAN to a central proxy. Instead, you should deploy a proxy and repository locally. That way, backup data stays within the remote site. So it might be the case that pretty much the backup server, the actual backup server, locates geographically far away from the remote location where we have our virtual machines, proxies, and repository. So basically the entire process happens here, while the backup server just to send management requests to the proxy server and to repository. It reduces significantly WAN usage and speeds things up. So and third, also while we need more proxy, its availability. If you have multiple proxies or repositories, one goes offline for an update or hardware issue, the others can take over. This gives you built-in redundancy. Veeam jobs will simply fail over to an available proxy, which means backups don't stop. That's the point for the backups our environment continuously without an interruption. So let's now break down that other component. So again, I'm talking a lot today regarding proxy, but they are very important. They are very important. And at this slide, we're going to consider what type of proxies we have. So types. There's the VMware, just a regular proxy for backing up vSphere environment. VMware CDP proxy for continuous data protection. If you're running a CDP replica, which one of the Veeam functionality, which is fully rely on the VMware, and this is basically the replication for VMware, when we rely on the VIO filter. Hyper-V environment, on-host proxy, off-host proxy. We will talk about this, of course, more details. Nutanix appliance, Red Hat appliance, Proxmox worker, and general purpose for file shares, physical server, and stuff. So here, this is a lot of different options. So for some of you, you need only knowledge regarding the web proxy or regarding Hyper-V or Nutanix. So in a next few slides, I'm gonna cover all of the proxy types one by one. So just focus on those which are yours. But the main idea for all proxies, this is the retrieving data, the virtual machine data from the production storage. So the proxy works with the production data stores. We connect, so we retrieve this data. We proxy perform all the processing, the compression, the duplication, encryption, and then send in the compressed, duplicated, and encrypted data to the backup repository. Or for example, to a disaster recovery site, to the proxy if it's a replica. That's very simple things. And so here's the one more thing regarding the proxy, the entire process for the proxy server. And then we will break down each type of proxy one by one. So let's take a moment to talk about how data flows during the backup, because it helps us to understand, or if when we know how data flows, it's easier for us to identify where is the bottleneck, what's the problematic component, where we need improvement, and how to track problems. It's very important for troubleshooting. So when the backup runs, Veeam creates backup files. So everything starts from the Veeam Backup and Replication server. We're connecting to our environment just to identify the list of the virtual machines we are going to backup. We initialize the component backup proxy and then backup repository. So during the backup process, we are going to create files such as the VBK, the file with the extension VBK for a full backup, and VIB for incrementals, and so on. But which is more important? Data movers. Veeam always uses two data movers behind the scenes, one for reading and one for writing data. If you ever look at the proxy or repository during an active job, you will see processes such as a Veeam agent.exe running, one for each task. These are data movers doing the actual work. So even if your proxy and repository are on the same machine, remember, on one installation, it might be the case we have the Windows-based physical repository, which is also acting as the proxy server. So even if we have all in one, we still have two data movers. Source, which will read data, compress, duplicate, encrypt, and target data mover. So communication between them will differ depending on the setup. If they are on the same box, Veeam uses shared memory. for efficient communication, so no need to go through TCP/IP. But if they are on separate machines, we use the network, and performance will depend on that link. So the communication between data movers will depend on a link between the components. So we're going to focus then on the Veeam backup proxies. So if you have the VMware environment, now this is the time to focus because we're going to cover the transport modes. That's important. We have 3 different transport modes. So at this slide, we are looking for the network mode. So here the bit of information regarding network mode. The network mode defines how the proxy reads data from source. And this moment, how the proxy reads data from the source, have a huge impact on the backup speed and performance, because it might be the case when we're retrieving a lot of data. So on this example, and the basically network mode is the easiest to set up and work in almost any environment. That's only mode that works if the proxy is the physical machine and the VM is on local storage. So basically data is read via ESXi management interface using network block device protocol. So NBD in short. If you don't know what kind of proxy mode you're using in your VMware environment, if you log into the Veeam console, locate the backup job, right-click on it, open statistic, and in a statistic, you see the line using backup proxy, your proxy name, and then the processing of a hard drive 1, for example, in a square brackets, you will see NBD. That means that your proxy is working in an NBD mode. So, for example, if ESXi host has only 1 GB per second connection for management, your backup will be slow because Veeam can only use part of that bandwidth, around 40–50%, because the ESXi needs the rest for the system operations. The ESXi pretty much blocked at least 40% of the entire connection for management requests. So, but if you have 10 GB per second or more, performance can be much better. So what's going on during the job process here? So the backup proxy sends requests to ESXi host to locate VMs on the data stores. The ESXi host locates the virtual machines, so where the virtual machine files reside on the data stores. So then VBR requests VMware to create a snapshot. So that's important also to remember that VBR does not create snapshot itself. We just request VMware to create a snapshot, and this is the necessary step in a job. So we ask VMware to create a snapshot. So after the snapshot creation, the disk will be placed in a read-only mode, so we can freely read from it. So you will see the snapshot created on your vSphere environment. You can open the machine, you can open the list of snapshots, and you will see the Veeam temporary snapshot created for this VM. It also will have a warning like do not delete place used by Veeam, which is also important, yes, because this is for the backup operation. So then ESXi host copies VM data blocks from the source storage and sends them to the proxy over LAN. And then after the processing, proxy sends data to a target repository. That's how NBD mode works. Very simple, but very reliable. So, and at this point, we can continue to another transport mode. We have virtual appliance. It also has a secret name, hot add. So you might look again in your statistics in the Veeam console. If you find a job, right-click, open statistics, list the information, go through the logs, you will see hot add in the square brackets, which means that your proxy is using virtual appliance. It's a special mode available when your proxy is the virtual machine. So it's significantly faster than network mode, and for many setups, it's the best option, especially if your proxy is already deployed as a VM. So, by the way, the proxy which is capable to do a hot add might be might be Linux-based and might be Windows-based, just based on your decision and which system you're more comfortable to work with. You can go with a Linux in order to save licenses. If you don't have available Windows-based license, it will work just fine. So the process, again, backup service sends a request to ESXi host to locate VMs. Pretty much the same. We locate the VM. ESXi host locates the VM. Then, again, we trigger a snapshot. Again, same. Then, look here where the difference happens. VM disks are attached, hot added, to the proxy. So we can retrieve data directly. We don't need to pass data over a network. So proxy retrieves the data. It's much, much faster. So then the processing is complete. The proxy finished the process and sent everything to the backup repository. VM disks are detached from the proxy and the VM snapshot is deleted. So while we attach disks, virtual machine disks, to the proxy server, nothing is happening with the production VMs. They continue working. So everything is fine in this case. So there are a few important requirements for hot-add usage. First of all, the proxy must be a virtual machine. It must be in the same data center as the VM it's processing. It needs to have an access to VM's disk. So this means correct permissions and storage visibility. Also, the VMware tools must be up to date on the proxy. So we expect a SCSI controller present for the proxy VM. So also there is a NFS 3.0 requirement. So we usually recommend to use NFS 4.1 with ESXi, especially if it's all earlier than 6 version, to avoid any limitations. There are VMware limitations connected to usage over the NFS 3.0. But anyway, that's a very convenient way to go. If you need more details on the transport mode, use a Q&A. And we're going to discuss the last transport mode for the VMware proxies, and it's direct storage access. The fastest and the most efficient transport mode available in Veeam. This method is especially recommended when your virtual machine disks are stored on shared SAN storage. VMFS LANs over fiber channel over Ethernet, iSCSI, or even a shared SAS. So the beauty of this mode is that it bypasses both the ESXi hosts and the LAN entirely. We pull the data directly from a SAN, which means no load on the production network and very fast transfer speeds. So let's walk through the backup process in a direct SAN mode. The backup proxy, to be capable for direct SAN, the proxy must be physical and has the access to the SAN. So, but the process. Proxy requests VM location. ESXi host locates the VM. So see the connection start from here. So the proxy is actually initialized this. After the snapshot is created and disks are placed in a read-only mode, ESXi host retrieve metadata about the layout of the VM disk on the storage, and then when the metadata discovered and read by the proxy. So proxy relies on this metadata to copy VM data blocks directly from the source storage. And the proxy just process copy data blocks as usual, compression, deduplication, encryption, and send to a target repository where the target data mover expects this data. There is some requirements, of course, because not every environment is a fit for this mode. It should be a physical machine as the proxy for this mode. The proxy must have a direct SAN connection. So that means hardware or software HBA. And it needs to be properly zoned and mapped. So the LANs used as VMware data stores must be visible in the disk management on the proxy, but we do not initialize them, of course. So this is just offline shared mode. So there are also some limitations regarding restoring data, because when we restore data, we still use the same transport mode. We have to be sure that proxy has right access to the target LANs. It only works with a thick provision disk during restores, but for backups, that's actually all of them will work. It does not support backup of the virtual machine templates, and there is also some limitations. You can find more details in a user guide, and I thoroughly recommend to use user guide. There is a step-by-step description of the installation. So just to make sure that you understand how it works, that it's easier for you to set up. And if you have any questions, you can reach out Q&A. And right now we move into Hyper-V. So for those guys who are on a Hyper-V, this is our time. We're going to consider Hyper-V. Hyper-V is simpler. It's two modes: on-host backup and off-host backup. Difference between two modes lies on the location where data is processed. Again, names speak for itself. On-host, off-host. So let's start with the on-host backup mode. In this case, Hyper-V host itself, where the virtual machine lives, takes on the role of the backup proxy. That means all processing is done directly on a production host, reading data, creating snapshot, sending to the repository. It works fine in many environments. This is totally acceptable, but you should keep an eye on resource usage, CPU, memory, network. If your host is already running at 80-85% capacity, backup operations may cause performance issues. So when we are backing up on newer Hyper-V versions, such as 2016 and later, we use the production checkpoints, which ensures an application consistent backup. So here, let's have a look at the process, how it looks like. So again, VBR queries VMs and virtualization host details from Hyper-V host. Then VBR instructs Hyper-V VSS to create a point-in-time VM copy using a volume snapshot or checkpoint. So here is the volume snapshot checkpoint created. And data is read from the read-only disks. Veeam transport service reads VM data from the snapshot or checkpoint, transfer it to repository. So also after the transfer, Veeam again requires Microsoft Hyper-V VSS full cleanup operations. So the important to remember that if your virtual machines are located on a cluster shared volumes on the Hyper-V environment, the host that owns the cluster shared volume will automatically take the role of the on-host proxy for that volume. So if you are trying to identify which host will process everything in a cluster shared volume, that's that one that owns the CSV. So overall, that works out of the box. Basically on host, you don't need to set up anything. It's efficient, it started working out of the box, but it can impact performance on a production host, so we have to keep an eye on it. Off host. This is where things get a bit more advanced. Instead of loading the production Hyper-V host, we shift backup processing to a dedicated machine, an off-host backup proxy. Off-host backup proxy, as a component, has to be added separately within Veeam Backup and Replication console. And this server does all the heavy lifting, reading, processing, sending data to a target, the Hyper-V host itself left untouched in terms of load. So how it works? Let's have a look at the process. Again, queries for VM and virtualization host from Hyper-V. So VBR instructs Hyper-V VSS to create a point-in-time VM copy using the volume snapshot or VM checkpoint. This snapshot is detached and mounted to the off-host proxy using transportable shadow copy technology. Veeam Data Mover on proxy reads directly from the snapshot and sends data to a repository. Once done, snapshot is dismounted and deleted. Since this is handled at the sun level, the process is very fast and puts basically no stress on network or production CPUs. So the off-host proxy must be physical, not a VM. Again, the cluster with CSV. So the proxy of host proxy must be outside of the cluster. So otherwise it can lead us to a LAN signatures conflict that can break the cluster. But this is a very nice thing to have. So off-host is perfect for you when you have when you want maximum performance and minimal impact on production system. But as I have mentioned before, so the on-host works perfectly well for the small environment. So then quickly, backup for Nutanix, Red Hat, Oracle, Linux, and Proxmox virtual environment. Very brief things regarding the architecture. So Veeam for Nutanix AHV environment. At the core of this integration are workers. This is what is the HV workers? Here it is. Lightweight Linux-based VMs that handle the data processing. They sit between the Nutanix AHV cluster and the Veeam Backup repository, pulling data and forwarding it in a Veeam's native format. By default, a single embedded worker runs on the backup appliance. That's fine for small environments, but as the environment grows, this can become a bottleneck. That's why for larger deployment, we recommend dedicated workers. These are deployed on individual hosts and allows for more parallel jobs and less strain on the appliance. So for those who works with a Nutanix HV knows that you have the backup server with a HV plugin. So we have a Nutanix HV appliance on the HV cluster, and so which works also as the worker. But you might deploy more workers. So very, very quick observation how it works. So when the backup job starts, either scheduled or manual, Veeam sends a command to the Nutanix backup appliance to begin processing the virtual machines. The appliance uses the Nutanix REST API to create a native Nutanix VM snapshot. This gives us a consistent point-in-time image of the VM without disrupting the workloads. Once the snapshot is ready, Veeam launches a worker VM. If it's the first time or a new session, it deploys the worker using the config stored in the database. The worker mounts the virtual machine's virtual disk using iSCSI and begins reading data directly from the snapshot. As the worker reads the data, it processes it, compresses, deduplicates, encrypts, if the encryption is configured, sends to the backup repository in a native Veeam format. So after data transfer, snapshot is deleted, and the worker VM is powered off until it's needed again. Agentless process work entirely through Nutanix APIs, minimize load on production VMs. For small environments, embedded workers can do the job. If you need scaling, we add additional workers. Done with Nutanix, move to Red Hat Virtualization and Oracle Linux Virtualization Manager. So if among the audience we have someone who uses Red Hat or Oracle Virtualization Manager, let us know in the chat and ask your questions, because we don't cover much for the proxies for Nutanix and for Oracle and for Proxmox, but you might have additional questions. Just don't hesitate to ask. So Red Hat virtualization or Oracle virtualization environments. Again, Linux-based worker VMs handle backup and restore operations. These workers are the link between the backup appliance and the rest of the Veeam infrastructure. By default, embedded worker on the backup appliance handles the job, which is fine for small setups, but in a larger environment, it's best to deploy dedicated workers. They help distribute backup traffic more efficiently, reduce bottleneck, and allow more concurrent backup or restore operations. So, a backup job starts. The job defines VMs to backup, where to store the data, and when to run. Veeam connect to the Oracle Virtualization Manager using REST APIs, create a snapshot of the VM. It then launches the worker VM, ideally in the same cluster as the VM being backed up. If no worker is available there, it will try another connected cluster or fall back to the embedded worker. The worker reads the data from the snapshot and sends it to the backup repository using compression and deduplication to optimize it. If it's incremental, Veeam uses changed block tracking to copy only the data blocks that changed since the last backup job run. Once the job is done, snapshot is deleted and the worker is powered off until it's needed again. Again, this is agentless architecture, so we can protect multiple virtual machines. We keep load off your production system as much as we can, and it's easy to scale. So the last hypervisor we're observing today in terms of the proxies, this is the Proxmox. If there are anyone from the audience who use Proxmox, let us know. Well, Proxmox. Again, we use Linux-based workers, which handle backup and restore operations. Again, this is a temporary virtual machines that act as the bridge between backup infrastructure and Proxmox cluster. By default, we will try to launch worker on the same host where VM is located. If it is not possible, we will try to connect another host. And let's observe the process. Veeam connects to the Proxmox virtual environment and triggers a copy and write snapshot on the VM. VMs, copy and write. Worker VM, it mounts the disk of the VM being backed up. So the worker reads data from the snapshot compares to the actual VM disks, excludes any changes. So here, like the difference, for example, we don't worker will do the change block tracking. So we use the change block tracking to optimize incremental backups. So to read, identify only those data blocks which have been already read and transferred. And that's basically it. Also worker like sends data to the repository. Once the job is finished, snapshot is removed. And the worker VM is shut down. So what we can see here. Veeam can protect Proxmox VMs without installing agents. It's scalable. We can just add more proxies to speed up larger jobs. Worker VMs are managed automatically and they only leave during the backup session. So it's helping us to conserve resources. So where is it? In the UI. In Veeam, you can deploy as many proxies as needed. So there is no license restrictions. By default, the proxy is installed on the same machine where the VBI server, but you can easily scale out. So to add the VMware proxy, in the Veeam Backup and Replication console, we go to the backup infrastructure. Under the backup infrastructure section, the first line at the top is the backup proxies. And here you can click add the proxy on a ribbon bar or right click on any available place here and go to add VMware backup proxy. So under the wizard, we get the VMware backup proxy, and we also have the entire list of different proxies. The CDP proxy for continuous data protection, Hyper-V off-host backup proxy if you decide to move processing from the Hyper-V host to somewhere else, to another dedicated server, Nutanix AHV, Proxmox, Virtual Environment Worker, General Proxy, but currently we're observing VMware. So in the VMware example, we choose the server, physical or virtual if it's already added. If we don't have anything, we add new and provide the IP address, DNS name, credentials. Then we can configure proxy. We have transport mode here. By default, it's automatic selection. And it's actually best to leave it as an automatic selection because under the hood, Veeam is capable to choose one which is working. So it will try if the proxy is physical and has a SAN connection, the direct storage access will be tried automatically. If the proxy is virtual, we will try virtual appliance and only then we will fail over to a network. If you specify any of these mode explicitly, direct storage access or virtual appliance, you can also perform the failover to a network mode if primary mode fails or unavailable. So we might always try direct storage access, but if something is not working properly, the failover will be performed. So also what we have here, connected data stores. This is optional filtering if you want a proxy to serve specific storage only. It might be, this is not necessary settings and it's not used oftenly, but you might need it in your environment. Concurrent tasks, a very important topic. What is the concurrent task in the Veeam? Task limit set for backup infrastructure components, and it influences the job performance. Each virtual machine disk processed equal one task. Veeam recommends one CPU core per 2 tasks, so as a 4-core proxy can handle 8 tasks in parallel. So for example, if you have a lot of VMs to process with a bunch of virtual disks, each of them, and your proxy server is only capable to handle 4 concurrent tasks simultaneously. In this case, all other virtual drives as a tasks will be placed in a queue. So they will be in a pending mode, waiting until the proxy is available. So here's actually a bottleneck. All right. Um, Whoa, we are here for the 5-minute break. So let's definitely take a 5-minute break. So I will share the screen with the timer, I think. And after the 5 minutes, let's uh, let's be here after the 5 minutes. Okay? Perfect. All right, we are back. So I hope you got a chance to grab some coffee and treats, and we are going to continue. So if you late from the break or you need like more time, don't worry. After today's session, we're gonna send all of your recordings and information, all with this, all slides that we have, all links, and there will be a recording. So you can get back to any part you want to listen once again. And we are going to focus on the backup repositories. That's a second important component within the entire job process, because here is the information how we actually store our data. And so, since we have started and we are back, just to understand that all our attendees back from break, just let us know a little bit that you're back in a Q&A chat, or just use reactions, emojis, thumb up. So let's talk about one of the core components in any Veeam backup and application deployment. This is the backup repository. So this is where all the backup data is stored. In general, we strongly recommend using physical machines for repositories. Why? Because they offer better performance and, more importantly, provide clear separation between your production environment and backup storage. So keeping backup storage isolated helps reduce the attack surface and avoid resources connection. So Vim supports a wide range of repository types. First of all, Linux or Windows servers. It might be even the virtual machines with a direct attached or shared storage. However, we do not recommend to have the repository as a virtual machine, of course, because it's the weak point. And we have hardened Linux repositories with immutability, network shares such as the SMB shares, NFS shares, deduplication appliances, Dell data domain with the ddboost license, HP store1 with a Catalyst license, Exagrid, Quantum, and others. Also, as the repository, you might use object storage, including Veeam's own Veeam Data Cloud. It's Azure-based Veeam object storage. So we will talk about Data Cloud and other object storage repositories a little bit later. So pretty much for object storage, you can see the list of supported clouds. So pretty much here, this might be any S3 compatible solutions. So let's focus on backup files. When the backup job runs, Vim creates backup files on the target repository. So the first backup produces a VBK file, a full backup. So the full backup always goes with a VBK extension. Later backups only store changes, and they are saved as a VIB, incremental backup files. There are also a VBM. It's the file that holds metadata about the backup chain and then all the restore points included. So if you have these several virtual machines included in your job, you will see the dedicated backup chain for each of the virtual machine on repository. The VBK equal to your virtual machines, the VIBs and VBMs. Also, there are different other extensions, different other backup job files. So it might be VRB, which stands for reverse incremental backup file, We have a reverse incremental backup mode, which is going to be legacy very soon. So we do not recommend to actually use it right now already, but you still can have reverse incremental backup chains in your setup. So this is a configuration backup file. If you remember, I have mentioned from the very beginning when we talked about the databases, I have mentioned that Veeam backs up its own configuration database itself. Here is the BCO file. Full backup for tape, archived log, transaction log backup, databases and stuff. There are a lot of them for unstructured data. So all of these slides you might see on your repository, and they're all heavily used by Veeam Backup and Replication. So depending on the platform, Veeam uses a data mover to transfer data. This topic we touched when we talk about proxies. You know everything about this already. The source data mover runs on the proxy, and the target data mover runs on repository, if your repository is a Windows or Linux-based server. So in this case, data mover runs directly on it. So again, in all-in-one setups, where the proxy and repository are the same machine, Veeam, we will see both data mover starts on the same machine. So if your repository is not a Windows-based, so in this case, the Veeam data mover will start on dedicated server, which is called the gateway repository. So also here, while we're on this slide with the Windows-based repository, I want to highlight that also we have an additional option, which is called Linux-based hardened repository. So starting from V12 patch 2, Veeam offers a ready-made ISO based on Rocky Linux. That's basically an image which is pre-configured according to the security implementation guide standards. It includes OS level hardening and secure backup settings. So it is perfect if you need an immutability and compliance. So the data mover also starts on the hard.linux repository, but this is only something which starts on the hardened repository. This is one of the options, and we're going to talk about this definitely a bit later. We have the dedicated immutability topic. Just wanted to mention. So if your repository is not a Linux or a Windows box, it's an SMB share or NFS share, Veeam uses a separate gateway. That is the role that handles all data writing. So the gateway might be a dedicated server in your environment. By default, the gateway role will be assigned to Veeam Backup and Replication server itself, so the data will flow through VBR. But you can assign the gateway role to a dedicated server in your environment. So, and then you know that Veeam Data Mover will start. So the gateway will bridges the data. So it will receiving data from the backup proxy and then writing it to your SMB NFS share. So same is going to happen when we have cloud-based or on-premise object storage, because from the S3 compatible object storage solutions, we might have a local appliances. So in this case, there is not a real cloud. This is something like the physical box in your environment, which presented as an object storage, or it might be the cloud-based object storage. In this case, data can be sent directly from the backup proxy to the storage. That's an option. So when the proxy is processing the data, as usual, compressing, duplicating, encrypting, and if it has a connectivity to the storage, the data will flow directly from the proxy and will be written to an object storage. However, in order to scale an environment, to distribute roles, you can assign the gateway role on the dedicated server here. So the gateway method in such cases is useful in environments with limited internet access, so that might be the case, and that's a secure option when the proxy server has no internet access. So you have NAT or the firewall restrictions. You might have a dedicated server which only the one point which has an access to the object storage. In this case, it's going to be your gateway. Especially if you have the bunch of proxies, that's for security perspective, that's not a good idea to give them all an access to the internet and ability to write data to an object storage. Since we have started talking about object storages, I want to talk to you about Veeam Data Cloud Vault. So, few slides ahead, we will focus on what Data Cloud Vault is and how you might use this in your environment. So first of all, this is the object storage offered by Veeam. It's fully managed. So basically you just acquire the storage. It's very easy to deploy. That's literally a matter of minutes. We don't need to do any configurations. So it's automated management because Veeam takes care of all the updates and support. So you don't need to actually do any administration tasks for this cloud storage manually. So the Veeam Data Vault is encrypted, isolated from the production environment. So this from the recent cyber threats. It's helpful reducing the risk of attacks because it's also immutable by default. And it helps us to with the compliance with security and regulatory requirements. The Veeam Data Vault has a fixed prices per terabyte with already included API call and egress traffic. So Veeam Data Vault ships in two editions, Foundation and Advanced. So the key difference is in geo redundancy. The Foundation edition offer LRS and Advanced offer ZRS. So LRS. So since on the background, what I would think, let's think of it as a Azure storage because from Veeam perspective, it's still Azure Blob. You can see here storage class, Azure Blob Cool Storage. Since Veeam has a partnership with Microsoft, we offer Veeam-driven Azure Blob storage for our customers. So in the foundation, we utilize locally redundant storage, which means that data replicated within a single data center, which protects, again, server level failures. In zone redundant storage, data is copied to at least 3 data centers within a single region. So protect not only from a server failure, but also the entire data server failure. So in the Veeam Data Cloud Foundation Edition, I would say that's one the big difference. And well, both of them, both editions are immutable by default, are encrypted by default. For you can specify the country or the entire Azure region, depends on your edition. So in use case here, you can see that Foundation Edition we usually recommend for secondary backups, and Advanced we recommend might be used for primary backups. So writing data directly from your production environment to object storage, directly to the cloud, to the immutable encrypted cloud, to make it absolutely protected from ransomware. And let's have a look at the architecture picture. So since the both editions, the foundation and advanced, presented at this slide for observation. So since the foundation use case is pointed for using it as a secondary target, let's imagine we have our backup server, and backup server process the data. So we put this data, our VBK and VAB files, on the local backup repository, Windows box, for example. After the data landed, it can be offloaded or moved with a backup copy job to a Veeam Vault, which is basically on the background Azure Blob cool storage with a local redundancy, country-specific locality, out-of-the-box immutable, and out-of-the-box encrypted. Or if you don't have anything, which also might be the case. And with Advanced Edition, you can write data directly to Veeam Vault. And if you need more information regarding Veeam Vault or you need a walkthrough, just you can refer to the Q&A. Okay, so since Veeam Vault, that as I have mentioned, is very easy to start. You can basically click on any Add Backup Repository window in Veeam, similar when we add in a proxy, select the Veeam Data Cloud Vault, provide the credentials, and we are all set. We don't need to configure much. That's very simple to start working with. So with a regular Veeam backup repositories, since by default in the initial installation, Veeam will assign the role of a default backup repository to the, as you can see here, we have default backup repository type Windows. This is the folder under C drive on the VBI server itself, something assigned automatically, and I'm pretty sure that in the majority of cases you have this. It might be deleted after you add something else, but by default it's here. So as an example, we are going to add Windows-based repository, and setup is pretty much straightforward. So again, we jump to the backup infrastructure. Then we go to the backup repositories. So after that, we go click Add Repository, and then we can select what kind of repository and select the type. Direct attached storage, Windows or Linux server, network attached storage, NAS device, for example, deduplicating storage appliance, data domain, store1, exagrid, quantum. So if we want to use a utilize native deduplication functionality of these appliances. Object storage, so object storage is a repository, and also the Veeam Data Cloud we just looked at. So we specify the direct attached storage. We're going with the Windows repository. Also, there is an option for Linux or for Linux hardened. I have mentioned quickly several slides before that we have a hardened Linux repository, which is immutable box, protected from ransomware. But we're going to talk about this later. So when we add in direct attached storage, we specify the server. And if we don't have any server added, we can click on Add New, provide DNS name, IP address, and add machine. We can populate the cache, populate the size, the capacity of the folder. We choose the folder for storing backups. We review available space using the populate button. We can configure task limits. So here is the path. Here are the task limits. Remember, when we talked about proxy, I mentioned the concurrent tasks. How many virtual machine disks the proxy can handle simultaneously. The same rules apply on the backup repository. So we can limit maximum concurrent tasks based on the amount of resources our machine has. So we can also limit read and write rate if we need it. And we have advanced settings. In the advanced settings, we have align data blocks, which is needed for XFS, ReFS, block clonings. If you add the ReFS, XFS repository from the very beginning, the checkbox will be here by default. Only if you change the file system, we might need to go and check it manually. The next thing is the decompress backup files, data blocks before storing. Useful for deduplication appliances. To overcome poor deduplication ratios during the writing compressed data, we select this functionality, check this box. In this case, data compression is enabled for a job. VBR compresses data on the source side, transport it to a target, decompress on a target, and write raw data to the storage device to achieve a higher deduplication ratio. So, then rotated drives. If you're physically rotating USB drives or disks, in this case, we need to specify these settings here. And the last option is the per machine backup files. Creates individual backup files per VM, which is recommended. So by default, for all the repositories which have been created after V12, this checkbox will be enabled automatically, so you don't need to jump and enable it manually. But if you've been working with Veeam for years and you have repositories created before 2022, 2023, so in this case, it might be the option that you still don't have it in place. And in this case, we can jump and enable it. So compared to other formats, this format allows managing individual workloads. So for example, if you have the bunch of the virtual machines in the job, and then one day you want to move one of them to another job, if you use permission backup files, you can move it because all the backup chains are absolutely independent, which is good. On the repository settings, we also have to specify mount server and vPower NFS. In the mount step of the wizard, we choose which server acts as a mount. This role is used for file level restores and application item recoveries. So by default, mount server role will be assigned on the machine itself if it's Windows-based, or to the VBI server. But you can select any other mount server within your environment. So what the mount server is doing? It's actually temporarily mount virtual machine disks directly from the backup file from repository. Backup files stays on repository in compressed and duplicated state. We mount the virtual machine disks to mount server without having to perform a full restore. And we can browse the content. We can verify what kind of file we want to restore, and we can perform the file level restore. So this is also a field for setting instant VM recovery cache. So this is where write changes are temporarily stored when VM is started directly from the backup. There is also an option. We have functionality which called instant VM recovery. In this case, we run the virtual machine directly from repository. And we mount the folder from repository using NFS, vPower NFS functionality to basically present the folder from repository as an NFS data store to ESXi host. And we're capable to browse the content, to browse the virtual machine files. And in this case, we can basically register the VM. Since the VM is literally not on the VMware data stores, we have to write changes somewhere. Changes are stored in a snapshot format. This is a Delta VMDK file, and we have to place it somewhere. So we specify the folder where it's going to be located, and that's basically why we use it. Also, instant VM recovery functionality widely used during the shore backup. It's the backup verification feature, and we will cover it later. So here we can enable it just to be able to run instant Veeam recovery and short backup. So later we are going to cover scale out backup repository. If you remember from the very beginning, we were talking about the entire backup process, and I have mentioned that we can pretty much easily add in additional proxies, and also if we decide, we can add repositories. If one of our repositories like hitting out of space issue, we're running out of capacity, we can add additional repositories, kind of a scaling, and we can do this with a scale out backup repository feature. That's the next point we are going to do. Okay. Scale out backup repository. Here it is. Architecture of a scale out backup repository, or SOBR for short version. Scalable option in Veeam. So instead of storing backups in a single repository, SOBR allows us to combine multiple backup repositories. In terms of SOBR, we call them extents into one logical pool of storage. From the Veeam perspective, all extents together act like a single backup repository. So, design benefits. We can scale horizontally. If you're running out of space, you don't need to migrate data. We can simply add another extent, and Veeam will start using it with no downtime or reconfiguration. Or secondly, we can utilize additional capabilities of each extent. And we can move data. We can enable tiering, offloading data from our performance tier, basically our primary location, kind of copying data to a secondary target and to an archive in order to meet 3-2-1 rule requirements and stuff. So, once again, what we call a performance tier. In the scale-out backup repository, performance tier stands for primary location where our data will be written. This is the first place where the backup files will land. It might be the bunch of the Windows machines, bunch of the Linux hardened repositories, different duplication appliance. For example, you have several Dell data domains in your environment, you can add them in a scale-out backup repository as a performance tier. So all the repositories that you have, and VBR will treat them as a single repository, as a one single resource pool. So you don't need to worry about the out of space problem. Or it might be also the case that you have just one machine in a performance tier, but they are added in the scale-out backup repository structure to utilize the tiering properly. That you have an object storage and then archive, the cold tier of a cloud for archival purposes. And let's have a look then at the settings. So in the Veeam UI, again, under the backup infrastructure, where we added repositories and where we added proxy, we have also the section dedicated to SOBR. We give it a name. That's pretty much it from the very beginning. So when you go to the section, you click Add, you give it a name, and then in the performance tier, we select repositories we want to include as an extent. There could be local disks, Linux repositories, duplication appliances, anything Veeam supports. There are a few advanced options here. Let's have a look. Veeam is asking us for extents. all repositories which have been already added in Veeam shown here. So you can just pretty much click several of them. And then have a look at an advanced option. Again, permission backup files, which we covered in a repositories tab, keeps a separate backup chain per VM. It helps with the parallel processing and it's recommended. And create full backup file, create full backup if required extent is offline. So imagine that you have 3 Linux boxes, all 3 of them added as a performance extent. So if one of them goes online, this option ensures that Veeam can continue the backup chain by creating a full backup on the another extent which is available. So this is just for management. Also, we define the placement policy, basically how we're going to keep data within across our extents. Data locality. Veeam keeps full backups and dependent incrementals on the same extent. It has its benefits with the block cloning if your extents utilize XFS or EFS and synthetic full backup files. Regarding synthetic and active full backup file, we're going to talk a little bit later, but probably you already know the difference between them. So the data locality, in this case, you can be sure that all backups dedicated to one VM will be written on the same extent, not to scatter it across, which is different for the performance. In the performance, this spreads full incrementals backup across extents. It can increase restore performance, but it requires strong network connectivity since restores may involve reading from multiple extents simultaneously. So usually we use the performance when we expect the data to be scattered across different extents equally. We can change anytime. If you change your mind, you can override the policy on a per extent basis. Let's jump to the next step here. Oh, I forgot about the strict placement policy enforcement. So if you want to strictly enforce your placement choices, you can enable strict placement and policy, which might cause the job failures. For example, if we are having the data locality, it means that we have to, Veeam must write incremental on the same extent where the full backup file for this VM is located. If this extent is unavailable, in a normal situation, Veeam will write to another available extent in a scale-out backup repository with no problem. If this checkbox is enabled, in this case, we strictly follow the rules. And the placement settings, if you want to specify anything explicitly. So for each extent, you can specify only extent for full backup and only for incrementals based on your choice. That's very flexible and scalable here. The capacity tier, very interesting thing here. There is where we extend our scale out backup repository to the cloud. So here's the checkbox, because you can create the scale out backup repository only for local machines and that's it. But if you go to the capacity tiers tab, click enable this checkbox, and then you can select or add your desired object storage. AWS S3, Azure Blob, Wasabi, etc. Then you can specify the data movement policies, copy or move. So copy backups to capacity tier as soon as they are created. As soon as the source backup job finished, the restore points identified as a repository that will be copied to the cloud. Good for redundancy. You have copy as soon as possible. Move backups after they are aged out of the operational restore window for freeing up local space. You can define how many days backups should stay on a performance tier before being offloaded, and also set a threshold trigger to force the move if space runs low. So also what we can do here, we can enable encryption for offloaded data. We can specify a float window here. Again. So sorry, forgot here to show you the move oldest files. If the threshold trigger. Here where we can install the threshold trigger. We can enable encryption and a float window. A float window lets you control when data is sent to a cloud. So for example, you can limit the business hours to avoid offloading, or to dedicate offloading only over the night or during the weekend. And we also have a health check. Health check for scale out. It's for the capacity tier and scale out. It's kind of different than the health check we have in the backup jobs. We're gonna talk more about the health check in the future slides. But so basically the health check is the option which verifies integrity of backups stored in an object storage. We check in cycle redundancy check, hash values, compare it with the metadata, with information in the Veeam configuration database, and that's basically it. So we have finished with the scale out backup repository, and we generally closing the repository section. If you have any questions regarding the repositories, that's just the right time to address them in the Q&A. Sure backup, our next topic. And I have to admit, I love it. That's the best feature ever. Sure backup, sure replica, and the virtual lab. This is something which allows us to verify the recoverability of our data, do antivirus scanning, perform some testing in an isolated virtual lab, and everything can be done within Veeam console, the Veeam backup solution. Quickly, about sure backup and why it's important. Of course, it's important because when we write data on repository, it's also important to know that we can recover from this data. We have to understand how much time it takes. We have to understand if the data is recoverable. And even if the VMs are recoverable and guest OS is bootable, we have to understand that our applications inside VMs are fine and consistent, ready to work. And for some companies, some of you among my audience today have to provide some reports to business, how the backups are tested, if they are fine, how many backups we have. So the short backup can build these reports for us basically, so you can automate the testing. So what we usually do? Usually we go to repository, take the backup file, run recovery, confirm it's fine, manually log in, check everything, then we can confirm. Sure backup, do everything for you. You don't need to do anything. That's perfect. That's why I love it. So sure backup is the combination kind of the operational job, which we call sure backup job, and the virtual lab. And the virtual lab must be configured properly. We also call it on-demand sandbox because you can use it for as your playground if you need to test something or teach newcomers. We can spin up the VLAB, run their virtual machines from backups, and play with this. That's perfect. So what the sure backup is doing, it's automatically spin up the virtual machines for testing. Once we define the lab, we have to create the virtual lab from the very beginning. We have a dedicated page in the user guide for virtual lab. This is a long talk about virtual app, so that's why we just leave it like that. Start with an isolated virtual environment. You can have a look at it, or if you want the dedicated demo, or you want to talk about the network settings and stuff, connect us in a Q&A chat. We can set up an individual session if you like. So, in Azure Backup, we create a virtual app and we create an application group. This application group, there is something that we can define manually when we, for example, need to spin up two VMs simultaneously in order them to pass some tests. We created Azure Backup job. In a job settings, we basically specify how many restore points we're gonna test, do we want them randomly, what kind of VMs we want to test, within what range, and how often the Azure Backup job will be running. We specify tests. Within Azure Backup job, we can test ping, heartbeat checks via VMware tools or Hyper-V integration services, applications checks such as SQL, domain controller, DNS, etc. Kind of, we just can select built-in roles. We can run custom scripts. So pretty much anything you want to test specifically. Antivirus scan, Yara scan for malware or sensitive data. These checks can run on schedule, daily, weekly, right after the backup finishes, and then you receive a report. So, quick look at the Azure Backup settings. It has two modes: full recoverability testing, when VBR runs machines in an isolated environment directly from the backup and perform tests against applications. This mode ensures recoverability of your production workloads. You just know that in a disaster event you're ready. And backup verification and content scan. VBR performs backup integrity check and content analysis to detect traces of malware or any other unwanted things. So antivirus scan, threat hunter, Yara scan. The backup verification and content scan does not require setting up a virtual lab. It's just the mount of the backup content and scanning it with an antivirus engine and with Yara. Both modes might be used at the same time or separately. Advanced features. What you can do with a virtual app. Outside of Azure Backup, you can use VLAP for your patch upgrade testing, application testing, penetration testing, run custom script without being afraid of affecting production data. Any changes inside the virtual lab are temporary. You spin up VLAP, test something, you stop it, everything cleaned up. That's the power of it. And here we're done with the Azure Backup and with an on-demand sandbox. This was a very quick overview, but as I have mentioned, I love this feature. I love two features. This is a storage integration and Azure Backup. I will talk about storage integration later, but right now let's focus on immutability. And immutability, this is something which is very important nowadays. Because based on my experience, I can tell you that 5 years ago, we did not talk so much about ransomware and malware. We mainly focus on doing the backups and recoveries. But right now, the backup solution is the part of a security things. And we have to prevent our data from being affected somehow by ransomware. And that's where immutability comes into play. I really want to stress how important this is. Because that's previously we talked about the backups as about something which the protection against hardware failure. But now we also have to be protected from ransomware. We are in a new era. Cyber criminals, they are everywhere. And it's not enough to just encrypt your production data. So, or they store them on somewhere. These also have to be immutable, because in this case, when the malware a ransomware jump to our environment, it won't be able to wipe out entire data from drives or just encrypt it and ask for ransom. So I would say that based on our experience, what we can see being Veeam engineers, we work with the customers, we hear the basically things from the market. In the majority cases, we have backups, so we can recover files, databases, VMs. But and cyber criminals also knows that recent viruses they are targeted to identify to go after backups first. They're like sophisticated ransomware way, so they actively look for backup files. It encrypts them or deletes them, and then basically crash the production, and then you got a ransom note. So for immutability, what is this? It's a simple concept. We make your backup undeletable and unchangeable for a defined period of time. So it also prevents us from an accidental deletion, so you cannot misclick, which is good. So no malware, no ransomware, nothing can touch the data until the period you set. Let's say 7, 14, or 30 days. Veeam supports different immutable storages, and we're gonna start with the Linux hardened repository here, but also it might be cloud options, Veeam Data Cloud, HP Store Ones, and Dell Data Domain. Veeam hardened repository, Linux-based repo. It can run on pretty much any hardware, Dell, Lenovo, Cisco, whatever you have. No special appliance needed. You have two ways to deploy it. You can set up a supported Linux distro manually using XFS within the block cloning feature enabled. You can find a detailed step-by-step guide in a Veeam Help Center user guide. We have all the commands you need written step by step. Or you can download a ready-made ISO from Veeam account. It's about 3 GB based on Rocky Linux. That walks you through the install with a wizard. It gives you a hardened, pre-configured, mutable repo out of the box. When you set this up, Veeam uses single-use credentials. So for the single-use credentials, let's one step back. Single-use credentials, like it means that we never know a root password. We never store root password. And after installation, the services run in an unprivileged mode, which makes system secure by design. And you never need to provide the root account. And the single user will be removed and must be removed from the system after initial installation. So then we set a mutability period, for example, 7 days. That means that nobody, even the most privileged user, can delete or alter those backups. We can enable also fast cloning. This is another feature for reducing the kind of a full backup file management. But yeah, that's basically other things are absolutely identical with the regular repository. So to object storages, here we are new object storage repository wizard. If we add in any object storage repository which supports immutability, they call them differently. It might be object lock, versioning for Amazon S3, S3 compatible, Wasabi Cloud, Azure Storage. They might have a different name, but still this is from the Veeam perspective, you see make recent backup immutable. So when you add object storage repository in Veeam, you have to check the box immutability, and that's it. Those backups were protected like in the hardened repository for the amount of days you specified. We also have a guide for step-by-step immutability object storage in the Veeam Help Center. And also I have mentioned that we support hardware appliances. Dell data domain and HP store ones via Catalyst license. So if the appliance properly configured, you can enable immutability, and the data which lands on an appliance will be immutable by appliance itself. That's very important. And if you have questions about configuring immutability, what is supported, how it affects retention, how to start using immutability right now, can you use immutability right now, please ask questions in a Q&A. Okay, and my another favorite topic, storage integration. That's really powerful because it allows us to work smarter when it comes into backing up data. There are three main areas where Veeam integrates with the storage systems: VMware environment, NAS file shares, and agent for Windows. We'll focus mostly on VMware for now, since that's where the most advanced integration takes place, but we'll briefly touch the others as well. So, to start working with the storage integration, we have to have the storage which support this integration. We have a dedicated storage integration guide, but basically if your production storage has a storage snapshot capabilities, so this is a bunch of them. In this case, you can basically integrate your Veeam with your storage. The key idea is, instead of relying on the VMware snapshot, we can integrate with the production storage to take hardware snapshot. And that can make your backups faster and reduce the impact on the production workloads. How it works? So we start by creating VMware snapshot. So that's as usual. So when we create the VMware snapshot, we need it anyway because we need to guarantee consistency. Then, immediately after the VMware snapshot is created, we tell the storage array to take a hardware snapshot of the volume where the VMs lives. Once it's done, we go back and delete the VMware snapshot quickly before it grows too large. The actual backup is taken from the hardware snapshot. And after backup is done, we clean up the snapshot on the array. So why it's great? Because the VMware snapshot only exists for a short period of time, which means less I/O impact, faster consolidation because data had no chance to grow large, and no performance hit to production VMs. So we pretty much can backup 24/7. This is a timeline representation for standard VMware backup and the VMware backup with the storage integration. So Veeam has to take a VMware snapshot, which essentially freezes the virtual disks at the point in time. But while that snapshot exists, new data keeps coming in, and VMware has to track all those changes in a separate Delta file. So now, if that snapshot hangs around for a long time, say during the large backups, the Delta file can grow huge, and then it's finally time to remove the snapshot and consolidate the changes back into the base disk. That's where the problems start. It can take a long time. It causes the I/O spikes, and in some cases, it even leads to VM data stun. All right. So, and for, as you can see, for the VMware storage integration, we create the snapshot and then VMware snapshot lifetime that's much, much lesser than in the standard VMware backup. So that's the main benefits, since the backup is pulled from the storage snapshot. So we do not load the production environment. And the VMware snapshot exists only for a brief moment, not long enough to cause any performance degradation. And that's actually quite good for our environment. So the configuration. In the UI, we have a dedicated section called storage integration. So you first need to add your storage array. So we go to add storage, then we can select from the list. Now we support a huge range of storage systems: NetApp, Dell EMC, HP, Pure, IBM, and others. Some of them are natively supported. So you just find them in the list and add them. Others use what we call universal storage integration. In those cases, the vendor provides a plugin that you install separately from the veeam.com, and then array becomes visible in Veeam. Once the array is added, you'll go through a short wizard of the installation. We are gonna go through NetApp on top, but they are pretty much similar. We give the array a name and role. So for what we're going to use it for, the VMware, for the Windows agent, NAS devices. Here is the list where specify role, basically. We provide the credentials. Usually this is admin, but we usually recommend to follow least privilege principle. So you can refer to the user guide for requirements, for permissions, and assign the role with the least privilege principle aligned. So we choose ports. Then we go to vSphere specific settings like NFS configuration, snapshot scope, proxy usage, and like what proxies to use, because in Veeam you can define the bunch of proxies, or you can limit which proxy can communicate with the snapshot. So also the mount service, etc. For NAS backup, for example, if you have a NAS filer, SMB shares on the NetApp filer, for example. So we can use storage integration with the file share volume to make unstructured data backup faster and less disruptive. So in this case, we can check what protocol we're going to use. That's pretty much important. And how it looks like in the job settings. Storage integration in a backup job settings. Imagine you're creating a job. In the storage tab, you have Advanced Settings button. If you click Advanced Settings button, it will open additional wizard with advanced settings for you. And we have an integration tab here. So here we have, by default, it's enabled. So as soon as you add a supported storage system, Veeam will try every time to use backup from storage snapshot. Also, there are additional settings for, you can set how many VMs per hardware snapshot. So you don't try to snapshot too many at once. And we also can enable failover to a standard backup, which means that if something goes wrong with a hardware snapshot, no space on array, for example, so a snapshot cannot be created, Veeam will failover back to the normal way, VMware snapshot alone. And that's it. So here's also brief architecture things, how this works. We have also ability to use two storage array. Let's say in primary and DR sites, and they are replicating data between them, like native functionality, NetApp Snap Mirror, for example. We can actually back up from a secondary array instead of a primary. So the production workload is completely untouched. The backup hits the DR array only. This is a great option for high availability. So, and for the Windows agent when running in managed mode, we can also use volume shadow copy plus storage snapshot integration to improve performance and reduce backup windows. But we are not going to cover it right now because we don't have much time. for so detailed observation. Just if you need additional information, just hit the Q&A chat and we provide all the necessary links for you. Another topic, very quick, tapes. That's important. Now, why tapes are still relevant today? Well, actually, tapes are still commonly used for offsite backups. They fit well into 3-2-1 backup strategy. That's 3 copies of data stored on 2 different types of media with 1 offsite. Tapes is a simple way to meet the offsite and media diversification parts of that model, especially for the long-term storage. The good news is Veeam fully supports working with tape libraries right from the UI. So Veeam Backup and Replication supports LTO and IBM Jaguar tape libraries, standalone drives, virtual tape libraries, physical libraries, and even partitions. You can share tape drives between the different Veeam servers. That's the only requirements that we have. But generally, we are absolutely fine and ready to go just from out of the box. Tape infrastructure overview. In terms of connection, we support both direct connection like fiber channel or SAS connection and remote connection like the iSCSI. We are pretty flexible here. To use tapes in the backup process, we need to deploy a tape server role. If you remember from the very beginning, I have mentioned that we have some auxiliary components which are optional, and tape server, this is one of them. If you use a tape library, you have to deploy it. This is a component responsible for transferring data to the tape library. It handles read-write operations, moves tapes, loads, unloads them, all of it. We can assign tape server role to any Windows or Linux server connected to the tape device. Often it makes sense to install this role on the same machine that also acts as a backup repository, especially in smaller environments. That way the backup sits on disk first and then gets copied to tape, simple and efficient. Once your tape server is connected and the drivers are installed, just add it to the Veeam UI and start creating backup to tape job. That's it. So all the data which is written to our main backup repository by our regular backup jobs will be copied by backup to tape job. It does not require any additional licenses. And recovery from tapes is available. You can recover VM directly to the production environment, or you can recover restore points to intermediate storage and then run from intermediate storage to production. Another important components, WAN accelerator. Let's take a moment to talk about WAN accelerator. One of the less commonly deployed, actually, but very useful component in Veeam. So, what is it? WAN accelerator is a dedicated Veeam role designed specifically for 2 job types, replication and backup copy job. So when we replicate original data from production to our disaster recovery site, or when we use a backup copy job we use to transfer data from our primary repository to a secondary target for redundancy. And the idea is pretty simple. We use WAN accelerator for the poor connection between our locations. When the copy job takes too long, we need to optimize one. And since the idea is pretty simple, it creates a cache of previously transferred data blocks. So when Veeam detects a block that's already been sent before, it doesn't send the full block again, just a small hash. The target site then pulls that block from the local cache. That cuts down the bandwidth and speed up things, especially over the slower links. So we have a source backup repository, data mover, source WAN accelerator, target WAN accelerator, which stores cache, and the target repositories. So how things looks like in the UI. To use it, we need two WAN accelerators, one at the source and one at the target. We can enable it when setting up a backup copy or replication job by choosing through one accelerator instead of direct. So to add server, add the one accelerator, choose the server or add a new machine. So specify the port and specify streams for us. Okay, so we also have a high bandwidth mode. So by default, the one accelerator works in a low bandwidth mode, recommended for links below 100 MB per second, and high bandwidth mode from 100 MB per second up to around 1 gig per second. So above the 1 GB per second, you are actually better off skipping the Veeam accelerator and letting proxies or repositories communicate directly. So we populate the cache. So we define the cache folder. This is where the global cache data is stored, mostly relevant for target one accelerator in low bandwidth modes. The cache size you set applies per source accelerator. So if you have multiple sources, you can use one target. The cache usage adds up. So by default, for proper cache, Veeam recommends at least 40 GB, but default is even 100 GB. So this is the cache size. By default, it will suggest you 100 GB. So, and the cool part, for example, if two remote sites are backing up similar VMs like a Windows servers, and one already has data cached, Veeam can reuse blocks from one source cache for another instead of sending them again over the WAN. So if you have a multiple, again, if you are the backup admin who manages several independent locations and you send data copying over to the remote target with a poor bandwidth, WAN accelerator might be our way to go. And also the more jobs run, the smarter and more efficient the one accelerator becomes. In the first run, you won't see any difference because it just needs to build a cache. And it gets better and better. That's the beauty of it. That's pretty much easy to install. And this is how it looks like in the job settings. In the backup copy job, under the data transfer section, we have a direct connection, which utilize the data mover starts on the repositories or data go through one accelerator. Same thing for replication job, when we basically transfer not to compressed and deduplicated state of data, but actual virtual machines to the disaster recovery. So here's also an option for it. And the last topic before break, Enterprise Manager. Then break, and then we go directly to the technical part, like how to build our first job and stuff. Very interesting. So just bear with me a second. The Enterprise Manager, important but quick. And again, important for those of you who manage the huge environment and you need a single management component. So this is a couple of slides here. What is the Enterprise Manager? It's a centralized web-based tool for managing and reporting across multiple VBI servers. It's useful in larger environments if you got more than one VBI server running. It's included in the same ISO as Veeam Backup and Replication. With the Enterprise Manager, you can control job operations, monitor activity, set up notifications, so search and recovery capabilities like recover VMs, individual files, perform application items recovery, everything from the single management installation. Usually we recommend to have it installed somewhere separately from the VBI server, the other side, the perfect location for Enterprise Manager. Installation process is very straightforward. You just go through the license agreement, provide the license file, you need the same license that you use for Veeam Backup and Replication, basically. There is no additional license needed here. Um, if there are any missing components, Enterprise Manager Installation Wizard will install them automatically. We have also customized settings if we want to pick up a specific SQL Server instance to make sure the database engine matches what the VBI server is used. If you remember, I have mentioned when I talked about the configuration databases and the Postgre and SQL, I have mentioned that. Veeam Enterprise Manager. From architecture perspective, you typically have one enterprise manager per environment, acting like a central hub. So let's say you have two sites, each with its own VBI server and backup infrastructure. Enterprise Manager pulls data from both and gives you a single view. Well, now let's say you've got just one license from Vimcom, but two sites. Licensing policy says you can't apply same key to two VBI servers directly. What you do instead is go to the customer portal, open the license case, split the key between sites, and this is called the workload is shared between sites. So in case we have Enterprise Manager present in our environment, we don't have to do a resplitting and stuff. We just install Enterprise Manager, apply the license to it, and it will automatically manage and balance license usage between the connected servers, between the site A and site B. So, capabilities. These are tabs for managing jobs, machines, files. So basically you can see the list of the virtual machines backed up, the jobs within all of your VBI servers. So we have the application items for recovery. And we have additional configuration tab for advanced settings and management. So here are the way how we connect the VBI servers, just the backup servers add and just give the IP or DNS and credentials. Under vCenter, you can also check which vCenter servers are integrated and deploy or remove the vSphere plugin if needed. So this is just for simplifying the process. That's only designed specifically for vSphere admins to make their daily life easier. Once installed, the plugin lets them interact with the Veeam Backup and Replication directly from the vSphere client. So you don't need to jump to Veeam console for basic tasks. From within vSphere, you can check the health of the backup jobs, see how many succeeded, failed, or had warnings. They can also monitor storage usage, view VM protection stats, spot any unprotected VMs that might need attention, and run the quick backup or use vimzip to create a full backup without leaving vSphere. Another really useful feature is a self-service portal. You can delegate or restore access to other teams like DBAs, application owners. So instead of them asking you every time, they just log in and restore what they need. With scoped permissions, of course. No extra permissions needed, like actually no access to the full backup console. Behind the scenes, this works thanks to the Veeam runtime process, which handles guest-OS indexing and checks who the local admin are. So this setup is especially helpful in large environment. Roles. Enterprise Manager also comes with a built-in role-based account access control, which is great for delegating permissions securely and selectively. As an administrator, you can give users access only to the things they actually need. There is a portal administrator, portal user, limited access to their own backups if you have the administrator in place, restore operators that can perform only restores based on the scope you define. So that's quite convenient for the large scale environments. So as you can see, we just specify the time and type and assign the role. One of the really valuable features of the Veeam Backup Enterprise Manager is that it gives you a backup method for decrypting data. In case you have lost or forgotten the encryption password, or your KMS server isn't available. During the installation, Enterprise Manager, Veeam automatically creates a key pair. We call it the Enterprise Manager key set. It includes a public key and private key. The public key is used by backup server to encrypt their storage keys. The private key stays in Enterprise Manager, and it's used to decrypt storage keys, which is what helps you to recover encrypted backups or tapes even without the original password. And finally, licensing. So this is where you can provide a license, so Enterprise Manager can monitor and sync licenses across all connected VBI servers. You can view usage and protected workloads in the reporting tab. And that's it, basically, for Enterprise Manager. So next, let's get 5 minutes break. And thanks for sticking with me. Grab a coffee, check emails, and when you're back, I'll hand it over to Gabriel for the next part of our technical onboarding. I will support you in a Q&A the next part of today's webinar, and see you in a bit. 5 minutes break, start now.
All right, everyone. I think it's time to get back to it. We just have a couple more slides to go through, and then we will pretty much be ready to continue the rest of the day. So, my name is Gabriel, as my colleague mentioned. I will just guide you through some of the points regarding the main menu. Now, as always, the Q&A section is right there. Whenever there is a question, just let us know. My colleague Elena will take care of it. Now, on the main menu, basically, this can be found on the top left corner of the Veeam Backup Replication console by itself. It covers different type of configuration, I would say, that can be done at the level of the console. For instance, on this first part, we will just have a look at the credentials and the password. Now, there are four different sections that we can go for. The first one is the data center credentials. Basically, everything that sits at the level of the backup infrastructure, let's say some local repos or let's say some VMware hosts, all those credentials will be found in this window. Next, we will have the cloud credentials. Anytime we need to connect to some cloud services, automatically we will need to have those accounts ready, and this is where we will store them. The encryption passwords, whenever we are engaged with data encryption, let's say at the level of the backup jobs or at the level of, I don't know, maybe the configuration backup itself, everything will be stored here. And in the end, if we have any kind of KMS servers, we can pretty much manage them from this window. Up next, the users and roles, same as before, we will just engage with the main menu button, and then we will just start doing our jobs with the users and roles. At the level of the Veeam Backup Replication console, we can, of course, have multiple users, multiple user groups. All of them, they will have a specific role. From this window, we can also engage with the MFA, but we will discuss about this one in a second. We can also know exactly when we want to simply add a new user, a new group. We can use the domain for that part if we have a specific work group that we should be using or manually directly. It kind of depends on what we require. Up next, we will discuss about the roles. At the moment, there's five of them. The restore operator, this is the guy that can only perform restoration for a specific type of workloads. Let's say we have somebody who joins in the Veeam console and is trying to perform only restoration. Well, that user automatically should be listed as a restore operator. Next, we have the backup operator. This one is responsible for starting and stopping backup jobs. It can also perform copy and exports. Next, the backup administrator. This one can do pretty much everything at the level of the Veeam Backup Replication console, including creating, deleting, or editing users. The type operator will be responsible for any kind of type operations. And the backup viewer, this is more of a read-only access that we provide to the console. It's quite useful whenever the management will want to have a look, but we don't really want to provide them with any kind of rights to perform any changes inside the VBR console. Right, next one will be the global network rules. Now, the traffic rules, as we call them, those can be used in order to simply instruct our Veeam backup replication server to either use multi-threaded data transfer for the job sessions, or if we want, we can also schedule the jobs at the same time using those features, this type of configuration. We can also add our own rules, let's say from a specific IP to a specific target IP. We can also throttle or encrypt the traffic. We can ensure that, for instance, during business hours, we don't want for a specific type of traffic to have more than specific value. We can also make sure that we never throttle any kind of restore activity, and that's usually something that we recommend whenever we discuss about backup jobs, for instance. Sure, we can throttle them in order to preserve the bandwidth to a secondary site, for instance. But when we are talking about restoration, we shouldn't throttle them because we go with the assumption that it's definitely an emergency situation if we require for restoration to take place. Also, there is a possibility to configure some specific preferred network, I would say preferred networks at the level of the backup and replication traffic. We simply configure it from the beginning. Up next, the VM exclusions. Those will fall under the idea that specific virtual machines should not be processed, even if they are included in a job or a policy. We can also move forward with the options. There are multiple over here, such as the input-output control. We can simply, at the level of the Veeam Backup Replication console, perform some kind of throttle, and at the level of the data stores that we are using in terms of the backup jobs, for instance, we simply say, hey, make sure that you don't assign new tasks, or make sure that you simply throttle tasks at a specific MS. Quite useful whenever we are discussing about those huge infrastructure with a lot of workloads, and in some cases we are trying to preserve as much as possible the performance of those systems. We can also, if we know really well exactly what's the status of our deployment, we can set custom thresholds for individual data stores as well. Next, it will be the email settings. At the moment, we support SMTP, Google Gmail, and Microsoft 365. Now, we use those email notification, for instance, at the end of a backup job, or we use those email notification in order to send a daily report that will contains specific information like a failed job or success ones. Pretty much depends on the degree of visibility that I want to have over the actions of the Veeam Backup Replication console. Up next, notification. By default, those options are enabled when we first deploy VBR, and automatically we will just launch little warnings inside the backup jobs whenever we notice that at the level of the backup repository, we are kind of getting low on free disk space, or at the level of the production data stores, we are seeing the same situation. We can also enable notification at the level of the support expiration. So the contract, if it's expiring, automatically Veeam will let me know. Or at the level of the updates, if we notice that is any kind of new product or hypervisor update that we should maybe perform. The history, the first part in the session, it will basically control how many I would say sessions I would be able to see at the level of the history inside the VBR console. The second one will control how many weeks I'm keeping the data for inside the database. So automatically the second one will be the one responsible for making sure that I'm not overloading my database with a lot of historical data. Up next, we will just have a look at the console. Again, it can be opened from the main menu, as Veeam offers the possibility to use the putty utility, for instance. Now, the configuration backup, quite important, is this done directly at the level of the main menu once again. We do have the option to create those configuration backups manually if we want to do so. We can also modify the schedule or modify the number of points that we are keeping. We can also modify the backup repository that keeps it, and also modify the encryption of this file. Of course, we do recommend for the backup file encryption to happen, and also in case of an emergency and we simply forget what's the encryption password or we misplace it, in that scenario we will need to have this loss protection enabled, which means the Veeam Backup Enterprise Manager should be working. The VBR that we are trying to recover this configuration backup file should be connected to it, and the Veeam Backup Enterprise Manager will simply release something called the recovery token, like a one-time pass that will allow me to use that file even though I don't have access to the decryption password. So over here, that's the option to simply change the backup repository. This is the option to send notification as well if you want to do this. And this is the option to protect the configuration backup with encryption. From this window, if we go on a fresh VBR, we can also perform the restoration of the configuration backup. Now, we will just quickly go through some examples of the jobs, what's the logic behind it, why exactly we need them, because in the end, when we are discussing about VBR, everything is about jobs. Now, the backup server by itself will be, as my colleague mentioned before, the brain of the whole operation. Everything will be done by the backup server because, in essence, the VBR has this little thing called resource scheduler service. And this is the one that, first and foremost, will be in charge or simply providing resources on the jobs based on different attributes or criteria, such as the type of the jobs, the priority of the jobs, the scheduled start time of those specific jobs. And on that note, let's discuss a little bit about jobs prioritization. So this is a simplified list of everything. The order is from high to low priority. We can say that there are at the moment about three tiers. Now, the first tier, data restoration job, continuous data protection, and background system jobs. Those are really the most important things that are happening, and they will always receive resources from the VBR server itself. Data restore jobs, once again, we go with the assumption that we definitely need to perform a restoration, so no throttle should ever happen. This is the highest priority that we have. Continuous data protection policies, those are special jobs like replication, but much, much powerful since they aim to simply live replicate everything that happens inside the production environment. Automatically, we go with the assumption that this is quite an important virtual machine that I'm trying to replicate using this CDP feature. So I should not spare any kind of resources and I should allow this process to work however it likes. And in the end, the background system jobs. Those are quite important since they're engaged actively in specific jobs and they allow me to perform specific actions in the background, such as deleting snapshots or removing some of the older points. Since if I don't run them and I don't allocate resources for those type of operations, I would call them to run, automatically I can run into a lot of troubles with the rest of the components. Next, the quick backup job. This is on the second tier of highest priority. Quick backup job is basically a way to perform a quick backup of a specific virtual machine, and we will discuss about that process in a second. High priority job, those are set inside the VBR jobs themselves. This is the third tier of priority, I would call them. Now, once we enable this high priority option, basically if multiple jobs will start at the same time, automatically this one will come on top. Regular backup job and replication jobs. This is again part of the third tier of priority, I would call it. Automatically, they are quite important. Nobody would say otherwise. But at the same time, if I do get some troubles here and there, it's still not a huge deal. And in the end, backup copy jobs and archive jobs. We go with the assumption and putting them last because the backup jobs and replication jobs, let's say they're already running, so we already have one point that can be used in case of an emergency. Backup copy and archives, this is more on a secondary plan, since I'm trying to send a secondary copy somewhere or simply perform archiving, such as using the tapes or maybe going for an archive tier in the cloud. Who knows? But again, they go with the assumption that I already have an original backup job, so it's not that critical to have a secondary one as well for the moment. All right then, moving forward, this is an example of the backup process. Basically, we will have this Veeam backup service. That's one of the most important things that we have at the moment. This one will simply move ahead and have a look at the Veeam backup manager in order to process each job. Then it will check with the configuration database to see exactly what should be done. Up next, we will just communicate with the data movers since those will be responsible for sending the data from the source, which is, for instance, in my case, a hypervisor, to the target. Now, if everything goes fine so far and I'm 100% confident that the data movers, they are there, they are working, the next step would be to simply communicate with the hypervisor and request it to create a point-in-time copy of a VM or a snapshot in most cases. And in the end, the data backup is taken for using those data movers directly to the backup repository. And that's it. Those are all the most important components. Without any of them, the job will simply fail. Now, We will go to the example of creating a simple backup job. So straight from the beginning, we will have the name and the description. It's quite important to set up a naming convention at the level of the backup infrastructure. So if we have a new employee that must take our role or work in our team, we should ensure that it's easy to understand what's going on with those backup jobs, what exactly they're targeting, what exactly and for how long, and where the backup points should be kept. All of those things can be done with a simple naming convention, the same that an IT administrator would do at the level of the VMware, for instance. Now, there are multiple options that you can go for. You can go one job for each virtual machine if you have a smaller environment. You can structure the groups depending on the host. You can structure them depending on the nature of the workload, such as a job for databases, a job for general application servers. You can also go with the approach of naming them based on the location, such as this job will go for immutable storage or this job will be off-site. We can also go with the approach of defining the retention policies, such as daily, weekly, monthly. There are a lot of combination. The idea is whichever path we choose, we should stick to it. We shouldn't mix match those options because we will end up with a lot of backup jobs and nobody has any idea what any of them are doing. As I mentioned in the description, this will appear by default as the last field of a backup job. Automatically, we should describe exactly what's going on here in more words, I would say, than the name of the job. And in the end, the high priority as we discussed before. Next, we will simply just add the virtual machines. Now, when we're discussing about adding them, we have multiple options. We can have a look at the host and the clusters, select exactly what we want. We can also have a look at the VMs and the templates, pick whichever workloads we want to be included. We can have a look at the data stores. We can also have a look at the tags themselves. So again, this is also quite an easy way to select my workloads that should be included inside the backup job. Now, let's say we moved forward and we selected a specific set of workloads. Next, we can also perform exclusion. For instance, we can exclude entire VMs if we're adding a tag or a whole host. We can also exclude disks of specific VMs, and we can also exclude the templates for incremental backups. Up next, we will have the storage. This is the point where we are already choosing our backup proxy. And there are two options, automatic selection or defined manual selection. Now, with automatic selection, Veeam will just have a look at all the proxy servers that are available to it. And we'll just select which one is not so loaded, and also it will select depending on the performances. For instance, in my case, let's go with the assumption that I'm backing up a virtual machine coming from VMware. In that scenario, Veeam will prefer a specific transport mode, such as virtual appliance, against another type of transport mode, such as network. Or we can simply select the backup proxies all by myself. I will just force the job to not use any other component at the level of the proxy servers than the one that I am enforcing. Up next, we will select the backup repository, exactly where I want my points to be. In the beginning, when we create a new backup job, it will start with a full backup. So that's something generally available. There is basically at the moment no other way to do things. We need to start with a full backup job. The chain will move forward, but the full one is 100% needed. Then we will select the retention policy, either in days or restore points. This will be a fixed number that the customer can simply decide what should be put here. And then we also have the option to engage with the GFS policy. GFS stands for grandfather, father, son. It is a specific type of feature that allows me to keep specific full backup points for a longer period of time. Now, this doesn't mean that Veeam will create extra points. What Veeam will do is use the current points. For instance, I set up a retention policy for 14 days, and every Saturday, let's say, I'm creating a full point. Now, if I let if I leave this option as it is to keep weekly full backups for 4 weeks, automatically Veeam will not create additional points. It will just take the point on a Saturday, which is a full backup point, and just keep it for 4 weeks, no matter what's the retention policy that I set previously. And there are also advanced options at the level of the backup jobs. When we discuss about backup modes, we have the reverse incremental or the classic incremental. Now, reverse incremental will always be slower since the last point, basically the one from yesterday, let's say, will always be a full backup, and I will automatically always need to inject those incremental in order to create a full point. In the future, this will be deprecated. We will not use it anymore. It will continue working if you already have a job set this way, but for newly created jobs, that will not be an option anymore. We recommend, on the other hand, for forward incremental to be used. As mentioned before, we just start with a full backup point. Everything else is pretty much just an incremental. And in my case, on every Saturday, I create a synthetic full backup. Now, synthetic full backups means that I will have a look at the level of the backup repository. I will have a look at the last full backup point, which maybe happened last Saturday, and I will take all the incrementals that were taken between last Saturday and today, inject them into the last Saturday, thus creating a new full backup point through synthetic means. We call it synthetic because it's 100% created. I do not engage with the production environment anymore in order to take an active full backup, which is the option right below it. And in most cases, when we discuss about quite a strong backup repository, in that scenario, the synthetic full should be utilized. If, on the other hand, I want to move the load at the level of the production environment, in that scenario, I should go for active fulls. All right, active fulls basically means have a look at the production environment, read the whole point, and send it over. Now, at the level of the maintenance, we will have this little feature called storage level corruption guard. It is a feature that allows us to simply detect any kind of silent corruption, as we call it, at the level of the backup files. Now, this is advisable whenever we have a backup repo that we don't really trust, but at the same time is not advisable if we are discussing about specific backup repositories that are not really the best in terms of performances, such as the duplication appliances. We might get into a situation where we would notice it takes a lot of time for a simple health check to be performed. Up next, we will have the full backup file maintenance. We can force basically specific repositories to remove deleted items after a specific amount of days, and even force them to perform defragmentation and compact full backup files on specific days of the month. Up to the storage, the proxy will basically be the one who will perform those changes. First and foremost, Veeam can assist with inline data duplication. By default, if we are working with a Windows repository, let's say, or if we are working with a Linux hardened repository, in that case, Veeam is the one that should perform the duplication. If, on the other hand, we are working with a duplication appliance, 100% we should let the storage do its thing, because the deduplication that can be provided by their technology that is made for their appliance will always be superior to what Veeam can do. Up next, the exclusion of swap and deleted file blocks. This should be happening since I don't want to take a lot of storage from my backup repo. In the end, we will have the compression level. By default, this is set to optimal. Now, optimal, pretty much that's the best compression to performance ratio. We can also set the compression level to be extreme, for instance. In that scenario, on the other hand, the backup proxy will suffer a drastic CPU usage change. By that, I mean I will pretty much force it to compress data as much as possible. Storage optimization by default is kept to 1 meg, and this is the classic approach for pretty much all the backup repositories on the market. If, on the other hand, we are discussing about something specific like a deduplication appliance, maybe an Exagrid or a Dell data domain or an HP store ones, in that scenario, we should be extra careful on the type of storage and the model. Veeam do offer some specific guidelines on what the storage optimization should be done. For instance, in case of the HP store ones, it's always a 4 meg because it automatically works a little bit better since it's not the speediest of them all when it comes to performance. And the option to perform backup file encryption, as I mentioned, this is done solely by the proxy appliance. Notification, those can be configured to be sent after we are done with the job, either as simple as an MP notification or as email notification. We can also configure when they should be sent. For instance, notify me only on warnings or error, or notify me only on a success if I'm quite confident that the jobs will run without any kind of issues. And at the level of the vSphere, we can work with the guest license in cases where the application aware processing is not enabled. And we will discuss about that in a second in the guest processing step. And of course, the CBT, which is highly recommended to be used since it can decrease by a lot the time it takes for the backup job to finish. We also have the option to simply reset the CBT on each active full backup automatically. And at the level of the integration, we'll have the primary storage integration. By default, Veeam will try to use those storage snapshot. Even though no storage integration is present, it's not a problem. What we can do is simply fail over to a standard backup with that approach. So whenever the storage snapshots are not ready for me to use, or maybe there's a problem with the data stores, I'll automatically just go with the classic approach and have the VM snapshot ready. And in the end, the scripts, we can engage with the backup job itself in order to run scripts before and after the job. It's pretty much dependent on the type of the application that is basically working at the level of that specific virtual machine. In some cases, maybe I want to generate a specific file internally at the level of a Windows machine, for instance, or maybe I simply want to turn off a specific application and then turn it back on. It's depending. All right, up next we will have the guest processing, and at this level there are two options, the application-aware processing and the guest file system indexing. Now, at the level of the application-aware processing, we are using this feature whenever we have specific applications that we will like to have consistent backups for. And also, we might need a transaction log. Now, let's explore what the options might be. These are different for each virtual machine, so each one of them can have a different configuration. When we launch the application aware processing from a specific machine, we will have in the beginning the option to require the successful processing. This is recommended by default. If by any chance we cannot do it for whatever reason, we can automatically receive a warning inside the backup job. Up next, the VSS settings. Those are used for logs pruning, which are supported by various Microsoft technologies. And in the end, the persistent guest agent, by default, if we are discussing about a Windows, for instance, the application or processing is performed by a non-persistent runtime process. If, on the other hand, we deploy this persistent guest agent, automatically we remove some of that security and port requirements. Up next, for pretty much each one of the applications that we can see in the upper ribbon, we will have the option to perform the truncation or back up the logs periodically. For the SQL, we will use the exact same credentials that are used in order to communicate with the virtual machines. So we should be extra careful on that part. For Oracle, on the other hand, we can select a specific set of guest credentials that should have the sysdba privileges. Otherwise, I will not be able to perform the application or processing for it. and I will not be able to delete or simply back up the logs differently when we are discussing about the archived logs. Pretty much the same approach is for the PostgreSQL. We can back up the logs every specific amount of minutes, and we will need to have a user with super user privileges as well. Now, in all of those instances, you might have noticed that we have something called a log shipping server. By default, it's set to automatic selection, and usually you just need to have another server inside your backup infrastructure that fills that role. In most cases, it's already present, since if we are discussing about SQL, for instance, maybe it will be just another SQL machine, so it will always have something there. But the role of the server is to simply ensure I can ship the logs. That's pretty much all it does. There are not a lot of resources required for this, and all we need is just to communicate with the VBR server for that approach. Up next, we will have the exclusions, and we can perform file exclusions if we want. By default, this will be kept as disabled, but we can include or exclude specific folders or files. And the scripts. Now, the scripts, those will be executed at the level of the application we're processing, meaning Veeam will simply wait for me in order to connect to those machines and use those credentials. After that, if I'm successful or not, I will simply try to execute the scripts. Up next is the guest file system indexing. This is the second feature that's available at the level of the guest processing option. This one will assist me in terms of security. Now, when I create the index itself, I can pretty much check for multiple indicators of a malware attack, such as from yesterday to today, when we're discussing about backup points, a huge number of files was suddenly deleted or created overnight. Automatically, this is a suspicious event, and I will generate a malware detection event. Or some of the files have their extension changed over the night, and this new extension is found on our malware extension list. Automatically, the guest file system indexing will be the one who will assist me with protecting my virtual machines. Now, the guest interaction proxy, it's again set to automatic selection. By default, this role comes to the VBR when you first deploy the Veeam Backup Replication console. If not, you can select a new one. And the guest OS credentials, if we set only one set of credentials over here, that set of credentials will be used for all the virtual machines included in the backup job, but you can also set credentials individually for each virtual machine using this button for credentials. And you also have the option to test the credentials. We will perform two separate checks. The first one will be at the level of the network connectivity to see if we can reach that virtual machine. And second, at the level of the credentials to check if those credentials can be indeed used for the guest processing. Up next, we will have the schedule. We can run the job automatically if we want. If this option will be disabled, let's say, in that scenario, the only option to run a job is manually with a right click and a start, for instance. Now, there is the option to run a job daily. So let's say every day at 10 p.m. or every, I don't know, maybe only during the week, the working days. That will be another option. We can also go for a monthly. So let's say on specific months, I would take the last Sunday periodically. So every 8 hours, I will start a new backup job. Or I can have a cascade effect, meaning I can instruct my jobs to start one after the other. This is a very good way actually to ensure that multiple jobs are not overlapping. We also have the option of the automatic retry. By default, it's 3 times. So there will be 3 different retries that will be done at the level of the backup job if one of the machines fails. And I will wait 10 minutes between each retry. And in the end, the backup window. Now, We will simply terminate the job if we notice it's being run, let's say, outside of the allowed backup window. And this can be set with denied or permitted. Let's say I have quite limited resources on an environment and I want for my backup jobs to definitely not happen during the business hours. This is the option to go, or as discussed previously, we just engage with the network traffic rules. In that scenario, we do allow them to run, but they will just move slower than usual. In this scenario, we don't allow them to run at all. At the end of the summary, you will also have the option to simply check a box and run the job when you click finish. Right then, we will just take a quick 5 minutes break. Let me just ensure that we have the timer ready. All right, and I'll see you in a bit. All right, so let's pick it up where we left. We will just discuss about restoration next. At the level of the restore, Veeam does offer a lot of restore options. In order to reduce the time of the restore, we need to basically pick up exactly what we need. For instance, we can go with the classic entire VM restore, which is the boring approach, most likely. We can go with instant recoveries. As the name would imply, they are a little bit faster. Virtual disk restores and instant disk recovery, they pretty much do the same thing, but this time I'm targeting the disks of a specific virtual machine. VM file restores, on the other hand, I will just have a look at the VM files and pick them up and move them wherever I decide to put them. Guest files restores, I will simply browse the files of a virtual machine, and that the application items restores can be used only if we are discussing about, let's say, an SQL database, and I have application word processing activated, configured at the level of that specific backup job. Veeam also offers the possibility to simply migrate workloads. For instance, this VMware backup that is shown on the screen can be restored as an Amazon EC2. I can bring it to Microsoft Azure or Google Cloud. So I can simply create cloud machines directly from the virtual machine backup that I have. I can also restore it in the entire VM to the Nutanix AHV, for instance. I can even perform exports at the level of the virtual disks, basically export the content. And in the end, if I want, I can also publish the disks. It's a little bit different than the classic virtual or instant disk recovery. All right, then, just to get to an example, we will discuss about one of the most critical nowadays in infrastructure, which is instant recovery. Now, pretty much whenever we have a situation where one of the virtual machines they're simply failing, what we can do? Well, the data is already compressed and maybe even deduplicated at the level of the backup repo, but that will not stop me. Even if the virtual machine, the original one, is turned off or suffers any kind of, I don't know, a disaster or something similar to that, we can simply just use the vPower feature, and I can just simply bring it with an online migration from the backup repo directly to the storage. Now, this one, as you might notice, pretty much happens instantly. There is no entire VM restoration in place over here. No, I just take the files, I mount them using the vPower service, and then I can simply post it back into production. And this is the method that is also used whenever we want to restore data to a different hypervisor. For instance, I had a backup of not a virtual machine from VMware, I had the backup of a virtual machine coming from Hyper-V, and I want to simply switch the hypervisor. In that scenario, an instant recovery is the one that can be used. We can also discuss about switching from a physical server backup, let's say a huge physical database, a physical server that is running a database, and I want to just bring it to a virtual machine. That's not a problem. The instant recovery can be used for that. Now, the process of restoring to the cloud. Well, in case of the Amazon EC2 and the Google, VBR will simply deploy something called a helper appliance, but this is deployed only for the duration of the restore process. Immediately after, it's getting removed. We must think of this restore helper appliance as, let's say, a little proxy that is used in order to perform the restoration to a cloud environment. Now, we do recommend this to be used, even though this use is optional, because it will improve the restore performances. In case of Azure, on the other hand, those helper appliances are pretty much mandatory. After the process finishes, the helper gets powered off only. It's not removed, such as deleted, and it will remain in this powered off state until in the future we just start a new restoration. The guest files restore, basically we're using a middle server called a mount server. And this time I will just take the backup file from the backup repository, mount it inside the mount server, and this will allow me to simply browse those files, browse those folders, see exactly what I have over there, and then I can perform the restoration. Now, the restoration can happen, let's say, to the live environment at the level of the virtual machine, for instance, or I can also download them if I want. It pretty much depends on the need at that time. Application items restore, as mentioned before, this can only happen if we have application aware processing enabled at the level of the backup job. Multiple types of specific application coming from Microsoft can be recovered using this option. For instance, Active Directory, an on-premise Exchange, SharePoint, OneDrive, an Oracle PostgreSQL, for instance. Pretty much depends on how my infrastructure is looking. But if I do have those applications running, I should basically perform this application or processing at the level of the backup job and use the option to restore application items. Now, why would I do that if I have the possibility already to restore the full backup of the full virtual machine as a full virtual machine? Well, I can do that, yes, but maybe there are cases where I cannot wait for the whole virtual machine to be restored. Maybe I want just the application. And following up, we will just have a little example. In our case, we just go for the Microsoft Exchange mailbox items, and exactly as it's the story with the file level restore, it's like a mount. We simply just browse the files that I want to restore. I can restore it directly to the Exchange server that's located on premises, for instance, or I can simply export it as a PST file or save it to desktop directly. It depends on what I need to do at the time. Now, the process of performing a full entire restoration of a virtual machine. Basically, on the left side, I will go under backups on the specific repository that I'm looking for the backup. In my case, it's a disk repo. I will just have a right click on it and restore the entire VM, or in the upper ribbon, I can also select the entire VM option. Up next, I will just select which virtual machine I want to go for, and quite important, the point of this, because given the fact that the Veeam Backup Replication software works with the idea of incremental and full backups, I'll be able to select which point I should return to with this restoration. Up next, I will have multiple restore modes. I can restore to the original location, basically original name, original settings, original host, everything stays the same as before the quote unquote failure happened. I can restore to a new location or with the different settings. In that scenario, I want to restore to a different host. Maybe I want to change its name. Maybe I want the network to be different. It kind of depends on what I need to do at that time. And in the end, we can discuss about this staged restore. Basically, we will use an isolated data lab that will allow me to perform some changes before placing the VM in the production environment. This is important in cases where I know on a specific virtual machine I would have some sensitive data that shouldn't exist in the production environment. In that scenario, right before I perform the final step of the restoration, I can just delete those files, for instance. All right, we can also discuss about the quick rollback. Now, in case of an OS problem or an user error, I can use this quick rollback, which will only restore the changed blocks only. That's the only thing that it does. In most cases, this is really, really fast, but it should be used only for one specific virtual machine and only if I am 100% confident we should go for this option. As I said, it's quite fast, but we should read the documentation first on it. All right, as you can see, since we selected restore to a new location, automatically on the left side, I will have multiple options such as the host where it should be placed. Now, if I click on host here, I will simply just have an option to select a specific host from the environment in order to place my virtual machine on. Up next, the restore spool that I want to go for and the data stores. Now, I can also modify first the data stores, that's a given, or the disk type of each one of those disks of the virtual machine. I can keep it same as the source, so as I originally backed it up, or simply change it to a thin or the two ticks available. Up next, the folder. So this will allow me to place the VM on a new folder. It's up to me exactly depending on how my environment is looking like. And I also have the option to simply give it a new name. And of course, I can also restore the VM tags exactly as I found them at the time of the original backup. And the network, this will show me what will be the source, what the network was at the level of the source, and what the network should be at the level of the target as well. I can also disconnect it from the network. It's up to me. Maybe I don't want it to be connected to anything. Maybe I want to go to VMware and perform some extra checks. And in the end, we will have the option for the secure restore. Now, the content scan is basically performed um, it's basically performed prior to the restoration, and the data passes through a mount server that can have either the file from an antivirus engine, maybe at the level of the backup infrastructure I'm running an enterprise grade antivirus, or I can scan the point using Yara rules, which are user defined. And if a malware is found, I do have multiple options for it, such as proceed with the recovery, but make sure to disable the network adapter so it doesn't communicate with anything. Abort the VM recovery, so if something is found, simply close the whole process, or continue scanning all the remaining files after the first occurrence, so at the end I can also get like a small report with everything that was found. And the reason, this is depending from each customer to each customer. Usually, I've seen a lot of customers not really using this field, the restore reason. In case of the POC, for instance, they will just write in test and that's pretty much it. So again, not really used. And we will have the summary with the small option at the end of it to power on the target VM after the restoration is performed. Now, security. We will start by discussing about the security and compliance analyzer first. Now, this is a tool that was introduced in the newer versions of the VPR. At the moment, it includes about 11 security checks and 19 product configuration checks. Security checks, those are points that are around the Veeam Backup Replication console. Product configuration checks, those are specific security best practices that can be done inside the Veeam Backup Replication console. Now, it can be accessed from the up on ribbon. It's the last option, security and compliance. And when we launch it, basically it will do a full check. As you see, there are many points that are passed, many points that are not implemented. You might find some points that are unable to detect. At the level of the Veeam Backup Replication official user guide, we do have a list of all of those points and exactly what is being checked. For instance, in the beginning, when we say that remote desktop service should be disabled, automatically that's exactly what the Veeam Backup Replication software checks. And all of those checks are pretty much at the level of the Windows registries. So that's where we will just have a look at them. Also, we can simply suppress some of those, let's say, some of those points since maybe we are using an alternative technology. For instance, maybe a PAM solution is in place. In that scenario, we can say that some degree of security was already provided, and we don't really need to be that strict in respecting the list itself. So suppression, they can still happen. Of course, for each suppression, we will need to provide a reason for it. Right up next will be the multi-factor authentication. This can be enabled in the users and roles themselves, and only singular users, not groups, can have this option enabled. Basically, each time when we will try to perform the login on the VBR console, an OTP will be automatically generated on the authenticator on your mobile phone. Many customers are using different technologies. It's up to you as the user to simply select what works best for you. And here we also have an example of the classic authenticator. Right, the forest authorization, this is quite an interesting feature that should be used as carefully as possible. The idea is I do have multiple backup administrators at the level of the VBR console. But let's just assume that a set of credentials for one of those administrators have been compromised, meaning somebody can gain access to the VBR console through those credentials. In that scenario, if they will try to perform any kind of destructive action, such as trying to delete some backup points, trying to remove a backup repository, in that scenario, we will just ask for the second administrator inside the Veeam Backup Administrators list to provide its quote unquote blessing. So both administrators will need to agree on a specific change that can be considered destructive, of course. If I do have, on the other hand, more than two Veeam Backup administrator, in that scenario, the administrator that will be asked for a change and will have the approval as being pending will be randomized. Now, this is exactly why I told you guys before that we should be extra careful when you're using this feature, because if I do have multiple backup administrators, one of them is on leave, the other gets attacked, and I will ask for the FORAS authorization to happen, maybe I will be really unlucky and the guy that is basically on leave will be the one that will be asked for approval. And this is exactly how it will look like. In this scenario, the delete backup on NAS and the delete the repository, those are pending approvals. And usually the administrator has a fixed amount of time in order to answer to those requests, I would call them. Right up next will be the malware detection. Again, a feature that is present in newer versions of Veeam Backup Replication. This is focused on detecting malware or checking for suspicious activity. We are focused more on detection, not really response. When we discuss about Veeam, given the fact that we take care of the backups, we are focused on detection and prevention through immutability, for instance. But when it comes to a response, it's not much that we can do at that level. So we must always act and plan beforehand when we're discussing a backup infrastructure. That should be the main strategy. Malware detection, we do have multiple options for this. For instance, we can leverage the scan itself at the level of a specific backup repository, for instance, or a specific backup point. I can take that point and place it on a mount server and start performing the scan either using the Yara rules, exactly as mentioned before, those are user defined and free, or a specific antivirus. Now, the antivirus should provide me with the antivirus file, which is then uploaded at the level of the mount server, where all of those checks are basically performed. And I have multiple scan modes as well. The first one, find the last clean restore point, quite self-explanatory from the name. Find the last clean restore point in a range. So automatically I will need to provide with the scan range and scan all restore points in a range for content analysis. The last one pretty much acts as a full scan of my backup points to see if there is something suspicious that can be noticed. Another point would be at the level of a sure backup job. My colleague described before how the sure backup can be used for recoverability testing. I will also explain it here how it can be used for content scan only. And in this scenario, we don't require to set up a virtual lab. We simply need to let Veeam know exactly what would be the job, and everything will happen at the level of the mount server once again. Up next, we will have the inline scan. There are two types of scan, the encryption and text analysis. Now, the encryption itself, this is a process that happens during a backup job at the level of the backup proxy. We will just have a look if we notice any kind of encryption attempt at the level of the disks. Now, automatically, we will use a trained machine learning model. This one should be low impact, but in cases where the sensitivity will be set to extreme, we will notice a lot of false alarms that will be triggered at the level of the backup point. Up next, the inline scan. Now, the inline scan is happening at the level of the backup proxy. So the first one was for the encryption. This time is for the files and folders themselves. We will just have a look if we notice any kind of, let's say, files and folders that are suspicious, a lot of files or a lot of folders being deleted, created overnight, maybe some extension, maybe some onion links. We might never know, but everything that is passed through the backup proxy, it's automatically checked, flagged by the backup server if we find anything, and then stored individually at the level of the backup repo. Since data at rest, not much bad that can happen even if it's infected. Now, file detection, this one uses the file system indexing. It's exactly what I described, that's what I described before, but what is added as a new thing in the later version of the Veeam Backup Replication server, we have those indicators of compromise. Automatically, if we notice any kind of commonly used tools by hackers, we will simply just notify the user. And at the level of the malware definition list, we simply, if we have access to the internet, we will just update it ourselves. If, on the other hand, we are discussing about the dark side and there is no access to the internet, in that scenario, we will just simply need to manually update this malware definition list. Right, up next will be the signature detection. This is done through a specific detection engine called the Veeam Threat Hunter. In version 12.3, we combine the speed of Yara rules with the extensive detection capabilities of the antivirus solution. So if you're using the Veeam Threat Hunter, it's pretty much happening a little bit faster. If, on the other hand, we want to use our own antivirus, automatically it will happen a little bit slower since, once again, we need to pass through the mount host. Now, just some tips and tricks. For instance, quick backup and Veeam zips. We didn't discuss about the quick backup in the past since I wanted to reach this slide. Basically, quick backup means I will quickly perform an incremental backup of a specific virtual machine, but this is done without setting up a new job. Automatically, this will add an extra restore point to any existing backup chain that I'm running this quick backup for. But of course, given the fact that this is an incremental meaning only differences, I will need to have at least one full backup point already created for the specific virtual machine for which I'm running the quick backup. And then we have the Veeam zip. This is like a full VM backup. It creates an independent VBK. This can be stored in various locations, but this one will appear on the left side of the screen, not as a fresh incremental inside the backup chain, but under disk exported. So it's movable. I can take it out from there and simply copy it to a new backup repo, for instance. Those are the options: Vimzip and quick backup. Enterprise Manager and vCenter working together. So there is a specific plugin for VMware vSphere, which basically streamlines the backup management for vSphere admins. Now, the Enterprise Manager will just authenticate the account inside the VMware vCenter. Of course, there are specific permissions that are required, and the VMware vSphere web client will be able to showcase some of that backup data. Now, at the level of the VMware vSphere web client, it should look something like this. So it will provide me with information such as how many backup servers I have, how many proxies, how many repos, what's the overview on the VM, the job statistics, all of them that can be seen directly from the VMware vSphere web client. Copy and move backups. Those are two very important options at the level of the backup points. In most cases, they are used in order to move backups to a different repository or to a different jobs, or to copy backups, not move them to different repository. It can also be used to rebalance scale out backup repos or evacuate some of the extents of the scale out backup repositories. It's basically a way to manage backup points. And depending on the situation, such as I'm running out of space on a specific backup repository, or I want to include specific machines in another job, but I don't want to start fresh. I want to take the backups with me. It's kind of depending on the situation, but quite important to be used at the level of the backup infrastructure. Over here, you will see an example on the copy feature. Basically, the destination can be a backup repo, a local or a shared folder. And if we want, we can also set up the deletion of this backup automatically in a specific amount of time. Let's say this is a temporary change, for instance. Up next, the Veeam Extract utility. Now, this is quite useful whenever we want to perform the restoration of machines, even if the backups are removed from the console or the console is not installed. So what I can do with this one, I can use those points because in the end, they will appear as being independent from me. If I have incrementals on the other hand, those will be the dependent to the full backup points as well. So it should be used, as I mentioned before, in cases where I neither have the points anymore in the console or if I don't have the console at all. And we are almost done. Just a little bit of information on some specific other, I would call them classes or demos or labs. In our case, the hands-on experience with labs that can be requested. For instance, if you want to try out Oracle Veeam Backup for Oracle KVM, it's not a problem that can be done. Or if we want to have a look at the Veeam Data Cloud for Microsoft 365, a lab can be provided to us. Or let's say we want to have a look at the recovery orchestrator from Veeam. Automatically, those hands-on labs can be used in order to simply test out scenarios or play around with the product. And there is also the possibility to take the Veeam Certified Engineer or the VMCE certification. This is either instructor-led or on demand. It's available in about 100 countries, and it covers at the moment the theory and the labs. Now, at the end of this class, you will basically need to take the Veeam Certified Engineer exam. I don't quite remember how many questions are nowadays for this examination, but basically you will just need to answer to some questions based on the already pre-existing information that you gathered during the course itself. And over here, we also have some additional resources, such as the Veeam University, which are free on-demand trainings, the Veeam calculators, which should be used whenever we need to modify some of the backup repositories or we need to modify some of the backup infrastructure components, basically used also whenever we are discussing about scaling out my components or sizing them correctly. We also have the Help Center, which covers all the user guides that Veeam offers for all the products, the best practices guide, the KB on the security, so a library of all the knowledge base articles that we do have, the forums, and of course the community of Veeam. You can connect with different users on the forums. There are also Veeamers active that can answer to your questions. All of those topics are pretty much addressed by either engineers such as myself and Elena, or by product managers directly, depending on the situation. And in the end, you can also share your Veeam success story. This is something to get closer to our customers whenever, let's say, you do have a success story with Veeam, you used it for a long time, for a specific scenario, for a specific strategy. This can be shared with other users from the Veeam community in order to build closer relationship between us as Veeam and you as the customers. And that will be pretty much everything for today. I know it was quite a long session. I know that I've lost maybe some people along the way, but whenever you decide to that you need some assistance or you want to have a discussion, you can just refer to your local renewal representatives or sales representative. Ask them directly, hey, look, I want to chat with one of your engineers. Let's have a session because I have this list of questions. It's growing quite big, and I really need to discuss them with someone. I would like to thank Elena for today's presentation as well. And what can I say, everyone? Have a good rest of the day.